Hey everyone, welcome back again. And people who are watching me for the very first time, myself Shashank Mishra, and I've been working as a data engineer. And for me, it's been almost 5 years in the big data domain, and previously worked with companies like Paytm, McKinsey, and Amazon. So, as I said, my field is actually the data engineering and big data, and that's what we will be talking about today. And its main component, or we can say basically the entire tech industry, whatever we see, and this is the backbone, and we are completely dependent on that. And the topic is the databases. So, we will be talking about that one, database management system. And before starting this video, if you are new to our channel and watching any of our video for the very first time, then make sure to like this video as well, because this is going to be the very informative from 0 to the level N, so that you can get a complete understanding of databases, and also to get such kind of amazing content on a regular basis, make sure to hit the subscribe button as well. So yes, let's start with our agenda first. So the agenda is basically to set a background for the databases, its need, and slowly we will be talking about its component, its technicality, architecture related, and how it basically became the backbone of entire software or tech industry, why it is important, and different types of databases, and some very important things, right, which are even very important for the development perspective, the software development. And I know, at least if you are from student background, and like this could be your subject as well, the databases. I have done my like MCA, and in our syllabus this was the topic database, and one of the important one. So this is the entire agenda, and we will deep dive into this databases, and I will also share some cool case studies as well for real world projects, how its database looks like, and talking about its technicality. So let's jump onto that. First, we will start with the introduction of the DBMS, and within the DBMS, I mean, the first and very important thing is to understand the database keyword itself, that what the database, why we are calling it, and what like why we actually need it. So we first need to understand those terminologies, and for that we will first try to understand what is database. So as per the technical definition, or I will also try to elaborate in terms of the general definition. So just imagine, right, you guys are using the internet, and you are using different kind of applications. Let's say within your like mobile, you are using different apps, and on the internet, on the browser, you are using different kind of web application. So everything is the data, right? The very basic example, let's say you just go to cyber cafe to fill any kind of form, like examination form. So you go there, log in onto their website, and after that you fill your data, and everything is with them, and you will get your registration number, and they will keep your detail, and after some time you will get your admit card. So how this is actually happening? Let's say you just fill your information, and it is not somewhere stored, right? So how would they even know that somebody like Shashank has applied for our like examination? So this is the very basic example. In order to process something, and in order to just modify anything, and in order to play around the things, so you need the data. Without the data you cannot even do anything, be it any web app, be it any Android, iOS application. So data is everything. That's why this database was something which was discovered, and its technical definition is basically a database is an organized collection of data that can be modified, retrieved, and updated. And that's the true, and practically we have seen it as well. So if we are from the software background, so we know what the database is actually. So in technical terms, just treat it like a bucket, or treat it like a any external entity, right, which is able to store your data in any kind of specific format. So let's say you want to organize your books, so you will open your shelf, and you will place it like one after each, and that's how you placed it. And similar way, just whatever you want to store in the practical life, you have something for that to keep it, right? A box, a ball, and something like that. So even if we want to, let's say, store the data in some specific format. And why specific format? Because we are not going to keep this data for, let's say, like 1,000 years. We will be using it every day. There will be modifications, there will be new data coming in, and probably we will be cleaning up some data as well, like deleting part as well. So that's how a database is basically an organized collection of data which can be modified, retrieved, and updated. So nowadays in the modern tech industry, right, there are a lot of databases, there are different categories, and we will be talking about that one as well. But on like highly used, or you can say basically most often used database is something which stores data in the tabular format, right? Let's say you might have seen like the Excel sheet, right, in your laptop, where you create some column names and start filling the data there, right? So in the similar form, there is a database which can store the data in that format, right? And in that particular database, we call this shape of data as a table, and its granular shape is like row and column basically. So let's say we have 3 columns to store name and the college name and the marks, and there will be multiple entries for that. So it is as simple as that. Third is every website which needs us the sign up part uses the database, and that's what I was saying, because they will keep your data as soon as you make a login. Let's say any food delivery app, any e-commerce application, as soon as you log in, they will keep your data, and that is the entry point, and it will be stored somewhere and will be processed further. And this is true. That's why even I have highlighted the no internet. So there is no internet without databases, and that's true. If you're not able to keep the data, what would you process? So the part I was talking about the database. So here, let's say this music, right? Let's say that's the outer line. Treat it like a box, and what we called it as a database which is going to store the data related to the music. That's why I have labeled it as a music, and this outer boundary is, again, just treat it like an empty box where you are going to place your data. And within that, you can see, right, different types of data you can actually place here. So one table, so here this point was table, right? Within the database, we will be storing the data in the form of table, and which will contain the data in the shape of rows. These are the rows, and these are the columns. So one table named as artist, which actually store the data for artist. So let's say artist ID, name, and description. Similarly, albums. So album ID, album name, and description. Ratings, there can be another table like rating ID, album ID, and rating. So these are the kind of data we can store here, and this is the very simple pictorial notation of the row column kind of database. So let's move on to the next point. So here in the beginning, as I mentioned, now the tech industry has advanced a lot, and based on the different use cases and based on the innovation in the tech industry, we have different variation and different categories of databases. So in the previous slide, what we talked about, that was the most often used, where data will be stored in the form of rows and columns. Now I'll be talking about different categories which will actually store the data in different shapes and different format. So types of databases, first can be object oriented database. So this is actually related to the OOPS concept as well, object oriented programming concept. So if somebody is from the programming background and knows the object oriented programming like Java, C++, Scala, so there we have a concept of classes and object. Okay, so object is something which is an active entity, and each object will have its own attributes, its own behaviors. So similarly, we have a kind of database as well, which don't store the data in the form of row and table. It actually stores the data in the form of object. So let's understand it from the technical definition perspective. So object oriented databases are the databases that present data in the form of objects and classes. In object oriented terminology, an object is a real world entity for which we basically compute something and we use it, and a class is a collection of objects. So these are the standard and technical definitions. So if you just want to understand what's the example of such kind of databases, so Postgres is basically a kind of a database which stores the data in the object format. So in future, let's say in any of your development task or any of your software project, you might need this kind of object oriented database as well. And the choice of database will most of the time depend on the use cases as well, right? So let's say you have 10 things on your table, and at a particular point of time you want to use something. So first you will decide, right, at this moment which thing we can use and what will be the good fit for particular situation. And that exactly happens with the databases as well. And in real world development, that's how we design the things, right? So we know this topic as well, system designing, where we need to actually counter and where we actually need to decide what kind of database we'll be using, why this one, why not that one. So that comes from the practice, that comes from the industrial experience, and that comes from the experience of system designing and understanding the real world use cases. So next category would be the relational databases, and that's what we were talking about. So previously, the example I showed you, right, the music database, within that there were different tables and which were storing the data. So relational databases is a collection of data items with predefined relationships between them. Okay, so there in previous slide, if I can show you, we had artist, albums, ratings. So here you can see the relation, right? If you like simply understand the music industry, so we will have artists. Those artists will record some albums, and as a listener I will be giving some ratings to different kind of albums. Okay, so we know somehow these entities or these tables will be related with each other. Okay, although this data is separated, but somehow we will be doing a kind of lookup, or we will be able to make that mapping so that we can identify that this artist has recorded this album and this album has got this many ratings. So that's why this is called the relation, and that's what the relational database is all about. And in the RDBMS, these items are organized as a set of tables, and the data will be in the form of rows and columns. And the very popular example is the MySQL. So this is an open source database, which is a kind of a relational database as well, or we actually call it a transactional database as well. We will talk about those topics in the later slide, but here this is what we have for the relational database category. Next, the distributed database. So this is the actual part of the big data ecosystem as well, because these kind of RDBMS system or relational databases have some limitation of scalability. And when we talk about the big data, volume is quite big in the terabytes, petabyte, and like exabyte. So here obviously we need something which can scale. And when we talk about the scaling, so we are actually talking about the horizontal scaling, where we can add more and more commodity hardwares whenever we need, and we can store the data in the distributed format so that we can get the fault tolerance as well. Our data is not lost, and our data is not lost because of the data replication and other things. Those kind of facilities will be provided by the databases, which are known as the distributed databases here. So in the distributed databases is an integrated collection of databases that is physically distributed across sites in a computer network, and that's what we are talking about. So when we talk about the bunch of commodity hardwares and like bind it together with a computer network, so that will be known as a cluster. Okay, and as soon as we are storing something, that will get distributed on these kind of nodes, and that's how you achieve the data distribution. So there are many well popular and like you can say most often used distributed kind of databases. So we have Cassandra, we will be having HBase as well, we will be having MongoDB, okay, and many other. These are the actual example of the distributed databases which I have mentioned here as well. Next, the hierarchical database. We might actually face a situation or a use case where like somehow we need to design a kind of database, and within that database data will follow some level of hierarchy, right? So just imagine a tree data structure kind of thing, where we'll be having the root and left node, right node, leaf node. So that is also one of the hierarchy. Same in the graphs. So a hierarchical database is a data model in which data is stored in the form of records and organized into a tree-like structure, right? Or we can say parent-child structure, in which one parent node can have many child nodes connected through links. And the example for the hierarchical a kind of database is the IBM Information Management System, like the developed by IBM, and the actual complete name was IBM IMS, Information Management System. So this database actually stores the data in the hierarchical form, like in the records will be actually created in the form of nodes, and all those nodes will follow some kind of connection with some links. So this is the theory behind the hierarchical databases, and these are the four most important categories of databases, and I have talked about the examples as well. So next, move on the actual part, the DBMS. So first we try to understand what is the database. Now we will see what is DBMS. So to understand the DBMS, the technical definition is it is a database management system, which is a kind of software for storing and retrieving users' data while considering appropriate security measures. So previously we talked about the blueprint. The database was a kind of blueprint. But let's suppose one thing, that even when you work on the application, web application, or any software, right? So you will actually create different services for it. You will create different components for it, so that you can actually use an application. Let's say, again, the very simple example, you have any application in your mobile, and as soon as you open, if it don't have any sort of UI, and if don't provide any kind of search button or any kind of let's say add to cart button, how will you be able to access the particular item and any kind of data? Obviously you won't be available, obviously you won't be able to do that. So same goes with the databases as well. So databases are very base layer for anything, like, and the technical thing, it was a basically thing to store the data. But in order to just access it programmatically, in order to access it via some application, via some network, right? So you need a kind of software layer which will basically manage everything for your database, right? Giving you the entry point to basically make a connection, and like giving you the entry point to insert the data, update the data, retrieve the data, and even applying some very important security layers, because data is crucial. So that's why DBMS is basically called as the software which gives you these kind of facilities, and so that you can work on the database. It consists of a group of programs which manipulates the data. That's what I said. Because if you don't have those kind of instructions, right? If you don't have anything like that available with you, how would you able to command your database that I am sending this data, you need to store it? So who will do it? This set of programs, or that software layer will do it for us. The DBMS accepts the request of data from an application, instructs the operating system to provide the specific data. That's how the entire this back and forth works while like manipulating and retrieving the data. In large system, DBMS helps user and other third party software to store and retrieve the data. That's what we have different kind of databases as well. They have different mechanism to store the data, and those, like, we call them as a DBMS, complete DBMS, which gives every component, and that can be used by any user, any program, and any software application which will make connection and store the data in the physical location. DBMS allows user to create their own databases. So in this first slide where I was talking about the outer bucket, which was named as music. So let's say, just imagine a very large warehouse, right? Where like n number of people can go, and they can just buy some space and they can put their own thing, and you will be provided a label because that is specific to you. So similarly, right, in a kind of DBMS system, any user, there can be n number of users, and every user can have their own database, because it's a kind of DBMS is a complete managed application for you, right, which provides these kind of facilities so that different kind of users can create their own databases, and we can store the different kind of data whatever we want. So here, if you see, right, this is a very simple example at how we actually different application or different kind of things can use the database. So this is the application, these are the users which are interacting with the databases and pulling the data from the database which is actually stored here. So that's how the DBMS, this is basically a point which is referring. So API is something, again, set of you can say program or set of instruction which will interact with the database and will fetch the data from this point where our data is stored on the physical devices. Based on the API instruction, it will pull the data from that specific database, from that specific table, and will just pass it back to the API if it was queried from there, and same the user and any other application. So that's the whole fundamental and the technical aspect of the DBMS. Now we'll be talking about its characteristics. We will try to understand what are the different characteristics of the DBMS. So the first characteristic is it is the real world entity. Obviously, we basically talk about whatever we think, right? Whatever we want to store in the world of databases, whatever we are trying to keep, that is somehow a real world entity. Whether we talked about let's say any user data, so user will have a name, they have their age, their address. So these are the some real world and practical things, and that's why we call it like a any kind of storage system which holds the data for real world entities. Next, the relational databases. So relational databases was one of the type for the databases we talked about, and even to work with the relational kind of databases, we will have a DBMS, and ultimately it is known as the RDBMS, Relational Database Management System. And we know the simple property of RDBMS, like every table will have some sort of link or some sort of relation with each other. Structured query language, this is the important part as well, and one of the important thing. And in the shorter form, we know it as a SQL, right? So in simpler form, how can I explain it? Let's say you are learning Java, you are learning C++, you are learning Python. So these are the programming languages. In programming languages, what we do, we write some set of instruction, and those programs actually accept some kind of input from the user, and based on that input, that program will get executed and we will get some kind of output generated from it. So same goes with the like SQL as well. So SQL is a kind of language which is designed for the databases, so that we can use this language, and whatever logic we will be writing in this logic, that means that will be transferred to the database. And that is nothing, basically a language which is specifically designed to communicate with the database, right? In order to insert, in order to update, in order to delete, and in order to do any kind of query, or in order to do any kind of data manipulation on top of it. So this is the kind of language which is designed specifically for the databases. Isolation of the data and application, and that's true. If this concept of database actually provides a application. And the next is isolation of data and application. That is also true when we are talking about the software products. We will see the application part, right? Whatever user is using, that is the application part, and its backend is somewhere else, and that is actually communicating with the, you can say, the databases. So we can see the clear segregation. Your application, the actual component which consists the actual logic, is a separate entity, and your database is separate entity. So they are not you can say running in a same box. They can be like placed on different places, and they can communicate with each other. So the concept of database actually provides this sort of isolation. And let's say it was not there, so somehow application had to manage this data as well, probably storing it in memory and any kind of mapping. But obviously that is not a practical solution, because we also have a limited memory, be it the external part, be it the in-memory thing. So that's how the data base is something which provides this sort of isolation. Next, the ACID properties. So these are specifically related to the transactional databases, and we will be talking about it in depth, like what is ACID. As a like full form, we can understand it. A from the atomicity, C is consistency, I is isolation, D is durability. So these database management systems actually provide this kind of important properties which makes it a transactional, which makes the database consistent, and many other technical stuff. Next, the multi-user and concurrent access. So database, as I already said, if you imagine a large data warehouse, similarly, the database is something, one of the entity which can be used by multiple user. I can access the same database, and another person can also connect to the same database application, and we can have our different database within the same DBMS, right? So that's how the multi-user and concurrent access at the same time, like obviously n number of people can point to same set of record, same set of the table, or same set of the database, because that's how, like in the modern application, every minute like there will be thousands of the concurrent requests which will be like trying to access the similar data, right? Let's say I can access the same record for different business logic for different purpose, and somebody else can use the similar record and similar data, similar table for their own purpose. So concurrent part is something which is important, and the multi-user thing which is the important part of the DBMS systems. Next, the transactional processing, that is again one of the part of the ACID properties. When we will be talking about that one, we will get the good idea what the transaction is and why it is important. Third is the and the next is the less redundancy and consistency. So these DBMS are actually designed in such a way that our database will always be consistent, and like there will be very minor chances of having the redundancy if we are following the best practices to avoid those kind of redundancy. So that's how these DBMS applications are designed, and we will also talk about it in the later section. Data security and integrity. So the integrity part is something which helps the database to maintain that level of consistency. If integrity, or you can say integrity constraints are not applied, our data won't be consistent. For an example, let's say I have declared one variable which is named as integer, and any random point of time if I am able to see float value in it, so this is the data inconsistency, because I defined it as an integer but it is holding the float value. How it can happen? So that's how the databases actually manage these things as well, so that data don't get corrupt, and data is actually consistent throughout the life cycle. And the data security, it also, like these DBMS systems also provide the mechanism, or you can say basically kind of set of instructions, so that you can secure your data and it can be only accessed with the proper authentication. So these were the some practical characteristics of the DBMS or the database management systems. Now we'll be looking at the important part and to like reflect the main purpose of having the DBMS. So that is the application of DBMS. Here I have listed down some important domains or industry related things where this DBMS is getting used. So first is the banking, and in the banking sector, how our database is getting used. And honestly telling, right, this banking and finance sector is something which is heavily dependent on these kind of transactional databases. And why it actually depends on those kind of transactional database. So let's say nowadays you are using the UPI system. As soon as you type 1000 and transfer it via mobile number or any UPI ID, instantly you get the message from your bank that this much amount has been debited and credited to somewhere else. So that is happening like just within a fraction of seconds. And you can even like understand in India actually the scale of banking and finance sector, it is very huge. And these like backend databases are running like a charm. They are handling millions of transaction requests per second, per minute, and they have managed everything, the complete concurrency or complete consistency of database as well, right? And that's the beauty of it, and that's why even banking sector is actually dependent on it. For customer information, they know who their customer are, account activities, whatever you have done, how many times you have debited the amount, how many times you have credited the things. They keep all the information, and that is something which is again stored in the database as well. The payments and the deposits, loans, etc. So these kind of information will be stored by the banks, and for that they will use the DBMS. Airlines, again, for reservation, scheduling information, and many other part. So like airlines, you can say any hospitality services, hotels, or any, let's say, car rental, or any other thing, right, which is related to the hospitality sector. Universities, they store the data for the student, their information, course registration, colleges, and grades. Telecommunication, it actually, this telecommunication part is something or domain which again uses the databases for different kind of purposes, like keeping all the call records and the monthly bills, maintaining balances, and what was the call activities, what you have done, how many or how much data you have consumed so far. Finance sector, again, for storing information about stocks, sales, purchases of financial instruments, and like bonds. And next is the finance sector, where again databases will be used for storing information about the stock, sales, purchases of these kind of like financial instruments, like stocks and bonds. Next, the sales department, use of storing customer, product, and sales information. Manufacturing, it is used for the management of supply chain, for tracking production of items, inventories, status in warehouse. So this is, I think, a very good example, right? Manufacturing or deliveries, right? Nowadays, whenever we want to send something, right, what happens, we just go there, and whatever the delivery service, we just send our package, and at every step we'll keep on getting the status, right? They will be giving you some tracking ID that, hey, your parcel actually has been dispatched, and this is the tracking ID, you can keep a track of it. So every time it actually reaches to any, let's say, intermediate point or any intermediate warehouse in a different city, you will get a notification, and that will be reflected in that tracking ID that your parcel has reached till this point. Next, the HR management, for information about employees, salaries, payroll, deduction, generation of paychecks, and many other things. So these are the some important sector, and this is not the specific list. This list is basically endless. So whatever we are talking about in the modern software development and modern IT industry, so there are multiple sectors, and every sector is depend on the data, and to store the data we need the database management systems. So this was something about the practical application of databases. Now we will move on to this important part, understanding the database architecture in DBMS. We understood the DBMS, which is a kind of software application which helps users, third parties, to interact with the databases in order to manipulate the data. But there can be different architectures of it. Within the DBMS, there will be different architectures, and now we will try to understand those sort of architecture, what is it, and like when you can use it, and what kind of application or what kind of architecture design should be there, where you should use different types of database architecture in your application. So first, the first architecture is basically known as the one tier architecture, and we will try to understand what is this kind of one tier architecture of database in DBMS and how it works. So in one tier architecture in DBMS is the simplest architecture of database, in which the client, server, and database all resides on the same machine. A simple one tier architecture example would be anytime you install a database in your machine, right? If you have a laptop, desktop, and access it to a practice SQL queries. But such architectures is rarely used in production, and obviously this architecture which we have talked about, one tier architecture, so let me explain it in the simpler terms. So let's say you have a laptop, you have a desktop, and when you work, right, when you actually install the things for the learning perspective, so what will happen in your local laptop, you will set up any kind of database, be it the MySQL, Postgres, right? There will be some steps so that that database is actually available in your machine. And in your simple system and simple machine, you can have a web server, right, which will actually listen to your like request which will be coming from the client, and that client can be anything it can be any web application as well, right? From there, whenever you will be doing some activities, that web server will capture those requests, and if that request contains any instruction to query the database, the data will be queried. So this is one example. So that's why it is said this installation in a single machine or in the local machine where client, server and database all reside in the same kind of host machine, right? So that is the example of one tier architecture. And even I'm again giving you a practical example. Whenever, let's say, you would have like installed any kind of database, as soon as you basically manipulate, or as soon as you try to make a connection from the command lines, right, there will be a command prompt where you can type the SQL queries and you can actually access the database. So this is the very simplest form of the database architecture in DBMS and kind of one tier architecture. Next, we'll talk about the two tier architecture. So in two tier architecture, DBMS is a database architecture where the presentation layer runs on a client, and that is can be like any PC, mobile, tablet, and data is stored on a server called the second tier. So that's how you can see this architecture diagram where the whole thing is actually divided in two tiers or two sections. So one is section is completely dedicated for the clients, and second is something just think like it another machine or another server where your database is running. Okay, so how this thing actually operates, this two tier architecture provides added security to the DBMS as it is not exposed to the end user directly. It also provides direct and faster communication. So in this architecture, we can like closely see whatever is the like client. It can be again any desktop, laptop, mobile, tablet, etc, and that is somehow accessing the database or even making a direct connection to the database. So that's why there is no middle layer in between. Okay, and that's why this point is actually mentioned, direct and faster communication, because there are no multiple hops in between from the client to the database. Client can make the connection to database directly and get the data from there. So this is the two tier architecture of database in DBMS. Next is the three tier architecture. So in this three tier architecture is something which is really common in the production level of services. So why I'm saying the production level kind of thing, so production level means here whenever we are done with the development task, right? Whenever, let's say, we would have started working on a software application, first we would have created its beta version, which will be running on a very low scale, and we need very less servers for that to handle the traffic. But whenever we just make those changes live, or whenever we make our product live, so that is exposed to the customer, that means hell lot of traffic will be coming and we need to handle it, and we need to handle these things in a real time in a production. So production is something which is exposed to the customer. So whenever we like go live with our systems or any kind of software product, so we will actually work on a larger scale of the scalability. We will actually deploy our application in the best architecture format as well. So three tier architecture is something is the most popular client server architecture in DBMS, in which the development and maintenance of functional processes, logic, data access, data storage and user interface is done independently as separate modules. All right, so separate modules, why I'm telling you, because here in this application you can see three components. First component is the client, second component is the server, or you can say the web server, and third component is the databases. So database is something which is separate, complete separate module, and its main responsibility is to just keep the data, and whatever request is coming based on the query, just manipulate, retrieve the data and just send it back from wherever the request is coming. And the responsibility of this server would be to handle all the incoming requests and pass it to the database, right? Make a connection to the database, perform the query, like whatever logic was sent from this client, perform it, and whatever the output data we are getting from the database, just again bundle it and just send it back to the client. So that's how in the three hops, three architecture, three layers are actually here. So this is you can say actually the complete database layer part here, and this is your application layer part here, and this is the presentation layer part here. So here, this is how the three-tier architecture actually works for the DBMS section. And now we will be looking at the different part. That was our three-tier database architecture in DBMS, and this is again something which is used in the production level things, and it will have a separate component which provides more decoupling, right? Things are not tightly coupled with each other, because that's how your entire application may like go down completely. And whenever we have a different things in a decoupled format, that means if something fails in between or as an individual entity, that can be recovered back, but that failure won't impact the entire application or entire thing. So that was about the three-tier architecture. Alright, so now we will start looking at the important concept in the RDBMS, like Relational Database Management System, and that important concept is the database schemas. So schema is the important keyword, and we will try to look at its different aspect, like what is the schema first of all, and different types of it, and I will also try to explain it with some like very simple examples. So let's look at it. So if I want to give you a very simple example of a schema, so just try to relate it with the programming languages. So in programming languages, what happens whenever we try to write any specific code? So first, definitely we will declare some variables. Those variable can be of any type, let's say the integer or some arrays, maps, or float values, strings, right? So those variables, that means they will be the actually name, or you can say a variable name assigned to any memory location which will hold that particular value, like whatever we will assign to it. And now in terms of the databases, when we talk about the relational database management system, where the actual data is in the tabular form, like the rows and the columns. Okay, so how we will be doing it, right? Let's say we have any RDBMS, right? Any database management system. Obviously we know it's a software application. So how it actually manages all these things, right? How we actually create the, let's say, database, and where the memory will be allocated, and after that once we create the table, right? So how our database will get to know that what is the table name, and main part is the what will be the attributes within the table. So this is the actual thing, right? So whenever we talk about the RDBMS related system where the data is in this form, right, the tabular or quite structured form, so the very first and very important step is to define its skeleton. Skeleton means, right, how it will look in at the overall picture. So defining that kind of skeleton, you can actually just relate it with the schema. So schema is something which is kind of blueprint of your entire table structure, that okay, how this table will look like. These will be the column names, and even those column names are the variable name assigned to those column values, right? And even those column values has its own type. Some of the column name might be of you can say the integer type, right? So very good example is, let's say the age, right? If you are not considering any float point, so 20, 21, these are the integer values. And similarly name, it's a string value, okay? And there could be a salary column which is holding the salaries, that could be float as well. So that's how, like, every individual attribute has its own type. And whenever we try to create the tables in the databases, so declaring the schema, or basically preparing the blueprint and the structure of any table, is known as the schema. And there are two different aspects of it, so we will try to understand it, which aspect lies where. So let's look at the technical definition first. A database schema defines its entities, right? Entity means the table, and the relationship among them. If there are multiple tables, there will be some attributes which are connected with each other, because we have also understood the concept of keys and all. So that will be the thing, like, which actually relates more than two tables with each other. It contains a descriptive detail of the database, which can be depicted by means of the schema diagram. So schema diagram is nothing, just you can say again the pictorial notation, like what is the attribute name. And in the later part of the this session we will be reading about the important topic as well, the ER diagram, entity relationship diagram. There this thing will be quite clear to you. So it's the database designer who designed the schema to help programmer understand the database and make it useful. So guys, if you don't know, even in this software industry there is one like common profile, job profile itself, the database developer, right? Or even the database admin. So what's their job responsibility is actually to deal with these things, even the complete admin related part of the databases, and also looking at the optimization part of it. And any business team or any development team comes to them, right? Because we will be creating those application, and at the end those application will be using some database for the data transfer and all. So that data will be in the structured form, and these guys will take help from the database developers, and the database admins will sit together and they will share their requirement that's how we want to design our database, right? And since the database developer is actually have the expertise in this section, so he can definitely design a well structured and well optimized database at the behind. So that's the thing. Now look at the schema part. So here in any of the database management system, there are two parts of the schema. First, we call it the physical database schema. Second is the logical database schema. Okay. So what is the difference between these two? So first, let's look at the logical one, and then we will look at the physical one. So this schema defines all the logical constraints that need to be applied on the data which is stored. It defines tables, views, and integrity constraint. So integrity constraints, like when we were talking about the keys concept and all, so I talked about this part as well, right? That in the databases we will be storing the data, and how it actually just maintain everything, right? How database doesn't allow, let's say you created one column which is of the integer type or something, and let's say you're trying to store the string value in it. So obviously this is the data inconsistency, and it won't allow you to do that because its definition is integer. Okay, so the rule which we have applied, that it has to be the integer, and apart from that we can apply multiple constraints on it as well. For every column we can define multiple constraint, like what should be the default value, whether it is a primary key. If it's a primary key, then multiple checks will be applied that it is not duplicated, and these things will be done by the database management system itself. But here this is the actual picture, like what you write on the paper and what you define and what you actually prepare while creating this table. That is the logical picture you are looking at it, like okay, this should be, there should be a name column, there should be a salary column, there should be an age column, and defining its data type, right? And putting some integrity constraint on it, and then like assigning some name to your table, something. So this is the logical schema. So here I will explain with this diagram as well that what is the physical part, or what is the physical schema, where it lies, and what's the logical schema thing. So physical schema, this schema pertains to the actual storage of the data and its form of storage file like indices etc. It defines how the data will be stored in a secondary storage. So that is the actual part for the physical schema. So again, let's take a step back where we were talking about the programming languages. What we did there, we created a variable name, and that variable name was like, it was just a reference to any memory location. But let's say we're typing on any coding editor, right? Let's say the Visual Code Studio or something. So there we type int a something. So for us, that is the logical thing which we provided to that editor, and under the hood or within the like computer machine and within your memories, it will be allocated in a different way, right? How many bytes will be created for any variable? If it is an integer, what kind of byte supports that kind of machine? So for integer it could be, let's say 4, and if you have defined the long integer, it could be more than 16 bit something. So that's how we can like just understand the definition of the logical and physical schema. So logical, what you define, right? And physical means how this data will be stored in the physical memory, because at the end, whatever you are storing in the data, that what at the end whatever you are whatever you are storing in the table, that is the data, and there are some numbers, some values, and they will occupy some space in the secondary storage as well, your memory, hard disk, wherever. So this is the thing, the difference between the physical schema and the logical schema. So everything will be taken care by the DBMS itself, like wherever you are like whatever kind of database you are using, so that will be handled, like what's the logical schema part, and deciding based on the system configuration that what should be its physical schema and where all things will be stored, because your DBMS will be the actual mediator who will interact with the machine or the memory locations and pull the data for you. So that knows everything. So that was the concept of the schemas, the logical and the physical. Now let's look at the important part, like where we were talking about the schema, diagrams, ER model. Let me tell you one thing, that this topic is quite important because in the previous part I mentioned about the database developer profile, and just don't think from the database developer profile, but also think from the system designing perspective as well, right? Let's say being a developer, you are working on a system, you are trying to design an application. The first step is that you don't jump onto the coding part first, right? First you work and you brainstorm on the design, that okay, this sort of database will be using this kind of components, will be using, right? High level design, low level design, everything you will be working on it. And similarly, to help anyone or to like help any development team or any developer to come up with a solid design for a database, this is a kind of, you can say, model, or this is basically a set of rules, methodologies, or concept or instructions which are mentioned in the ER model somebody can use to notate or pictorially visualize its database, how it will look, how it will be related, or how other tables will be related with each other, how to define the attribute, right? So that is the main concept of having the ER model. If you want to understand it in easy terms, so again, let's go back to the programming side. So there we have a concept of flowchart. Flowcharting, what happens before writing the actual code, we try to just write, or we try to draw a flow chart, like from where our program will start, and then decision box, then arrows if yes any condition, then where the flow will go, where the computation will happen. So everything has its own dedicated instruction, right? The decision box will look like a diamond, and what is the meaning of arrow, what is the meaning of the parallelogram kind of box. So everything has its own meaning, because that is the common structure somebody can follow, like across the software engineering, right? If I'm someone, I have written a code and I wrote it in a different language, let's say Java, okay, and there is another developer who knows Python, okay, so for both of us the things are quite different, right, in terms of the programming syntax. But let's say whatever logic I wrote, if I just draw a flow chart for it and hand it over to that guy who knows the Python, so he will able to understand the flow chart, because that is the common thing within the software engineering. Flow chart has its own fixed rules, fixed set of you can say instruction, so that somebody will design it. So common thing, right, and basically a medium to share the information, right, across the community, and somebody can convert that logic or that flowchart in its own programming language. So that is the same concept here with the ER model itself, just to pictorially visualize that how your entire database looks like in the logical form, like defining those entity name, table names, their relationship with their attributes and keys, and that's the main concept. So we will be discussing about that, and trust me, it's again important concept, and it also becomes important from the interview perspective as well, because interviewer might ask you a very straightforward problem statement, that can you design a ER model for the food delivery app. So you need to come up with the entities, that what kind of tables would be there, what kind of attributes they can have, and what would be the relationship with each other. So you should definitely know how to design a ER diagram and its concept as well, like everything, what is the meaning of every image, box, or anything like that. So let's try to understand it with the technical aspect, and let's try to understand the technical definition of ER model, and also what are different components of it. So ER model stands for entity relationship model. It is a high level data model. Like in the system designing, we have a HLD, like high level design, where you just draw some boxes and the arrows to just make sure what is the flow and how other components interact with each other. This model is used to define the data elements and relationship for specified system, like how those tables and the attributes will be connected with each other. It develops a conceptual design, the logical design you can say, or the pictorial notation for the database. It also develops a very simple and easy to design view of data, right? Because if the database things are clearly visualized in the pictorial format, it's very easy to understand how things look like and how like those tables are created. In ER modeling, the database structure is portrayed as a diagram called an entity relationship diagram. Now let's look at the three important components of the ER model, and after that we will talk about each and everything one by one. So first component of ER model diagram is the entity, right? Entity, and within the entity, you can say it has a one subtype as well, like weak entity as well. So two things, entity and weak entity. Second is the attributes, right? Attributes basically can be of different types as well. So attributes, just think the column names. So key attributes means what would be the column or the column name which will act like a primary key. So that will be known as the key attribute. And in order to represent within the diagram, in order to represent the key attribute, it has its own definition. It has its own rule, like how somebody can define, yes, this is the key attribute. So we'll be looking at that one. Composite attribute, multi-valued attribute, derived attribute. Third thing is the relation, because the entities which are actually the tables, they can be connected with each other based on the key relationship, the foreign keys kind of concept. So what kind of relationship they can have? Obviously we know this is the very common in the you can say the classes, object, and you can even say the database world, the kind of relationship, the one-to-one, one-to-many relationship, many-to-one, and many-to-many. So we will be looking everything with the example, and I will make sure that everything is clear to you for every important part. First, like how we declare and how we visualize the entity within the ER diagram. So entity, what it is, an entity may be an object, class, person, or place. So this is simply like in the beginning we talked about the music database, right? There was different tables, the artist, the let's say album, the music, the rating. Okay, so everything, artist is something you can say based on the definition object, class, person, or place, for which we will be talking about and for which we will be storing the data, right? So that is the entity. And in the ER diagram, an entity can be represented as the rectangle. So when we will be designing the ER diagram, how we will get to know that, okay, this is the entity, right? This is the actual table name. So we will get to know based on the representation. And in the ER diagram, we represent any entity with the help of the simple rectangle. So anytime you see any rectangle box and anything written into it, that means that is the entity. So here for the example, let's say you are working for a company, that company will have the employee data, okay, and how we can segregate that entire employee related database in different tables. So every single table will be like one entity. So if there can be one employee table, there can be one department table, there can be one, let's say, address related table, and many other things. Okay, so that's how you can see rectangle box, and within that this employee keyword is written. So that means this is one entity and this is another entity which is named as the department. Now let's look at the weak entity. What is the purpose of weak entity, how it is notated in the ER diagram, and what does it actually mean? So an entity that depends on another entity, right? So these are something which are the origin or the original, you can say. They are not dependent on anything. They have their individual existence. But here an entity that depends on another entity called a weak entity. The weak entity doesn't contain any key attribute of its own. I mean, it won't have any kind of primary key sort of column. The weak entity is represented by a double rectangle. So I will explain it with this example where we can see this is mentioned in this simple rectangle. That means it is the original entity. and there is one arrow, that means it is it has some relationship. We will talk about those things later. But here this installment entity is mentioned in the double rectangle. That means it is the weak entity. Now, why it is a weak entity? Because installment completely depends on the loan. How? Let's say somebody didn't took any sort of loan, then there is no concept of installment for you. All right. So similarly, if let's say this loan table is completely empty and this loan table doesn't even exist in any of the ER model, then there is no purpose to mention the installment as well, because somebody didn't even take the loan part. So there is no concept of installment, and that's why it is known as the weak entity. It is completely depend on the loan. Loan is there, installment will be there. Now let's talk about the next thing, that is the attribute, like how we actually represent the attribute, how it actually look like, right? So attribute, the attribute is used to describe the property, or again in simpler words, the column names of any table are actually known as the attributes. And here this diagram is little bit not correct, because the attribute which are mentioned here actually mentioned with the help of the eclipse, right? So whenever we want to define any kind of the attribute name, that will be enclosed within the ellipse kind of shape, right? Not this the complete circle, and that's what is mentioned here. Like ellipse is used to represent an attribute. For example, let's say we have a student table or a student entity. The common column name can be like student ID, which is simply mentioned here as the ID, and it can have another column name as the phone number, and it can have another column name as age, and obviously the name, which is the student name. So these things will be mentioned in the ellipse. These things will be mentioned within the ellipse kind of shape, not the this one, the exact circular thing. Okay, so let's look at the important part of the like you can say important part of the attribute category as well. So attribute category, first we mention the key attribute. What is the key attribute? So the key attribute is used to represent the main characteristics, or simply in very simple words, the primary key of that table, right? That is why it is the main characteristics. With the help of primary key, we will be able to identify the unique record, and it represents a primary key. The key attribute is represented by an ellipse within the text underline, right? So I will show you that, ignore this diagram. I will show you in the next one that what is the key attribute. So let's say this ID is the like student ID, because it is unique. Every student will have its own unique ID. So there will be one underline in it, like ID within the name of this, under the name of this primary key column name, there will be one underline, and that is the notation of the actual primary key. And I will show you one good example as well, the complete ER diagram. There, like everything will be clear for you, how every attribute is mentioned, everything. So that was the thing about the key attribute. Now we will look at the composite attribute, and here you can clearly see, right, the ellipse shape. So ellipse shape means that is mentioned as the attribute or the column name of that respective entity. So what is composite attribute? An attribute or a column name that composed of many other attribute is known as a composite attribute. So what can be the example? Simple example is the name column, because that name column can itself have like kind of three subcategories: first name, middle name, and the last name. So these are the attributes, right? These are the attributes which are helping this name attribute to get completed. Okay, if you don't have first name, last name, right, then definitely you won't be able to derive the complete name. So here it has nothing to do with the derive column or derivation, but here the example is quite clear, because this name attribute can be divided in the three parts itself: the first name, middle name, and last name. And when we combine these things, these three together, it will give the full name value, right? So these are the composite attributes. Now what are the multi-valued attributes? So an attribute that can have more than one value will be known as the multi-valued attribute in the ER model. And how we actually represent it? So that is represented with the help of double ellipse. So any attribute which is having more than one values, which can have more than one value, will be notated as the double eclipse. So here, this is the good example. The phone number, right? I can have multiple phone numbers, multiple SIM. I can have also multiple numbers, multiple SIM. So if somebody registers my data or somebody collects my data as a student and there is one phone number column, I can mention more than one phone number there. So that attribute is capable of containing more than one value. So that's why it is known as the multi-valued attribute. Now let's look at the other part. What is the derived attribute? So derived attribute, an attribute that can be derived, or a column like which can be derived from another column, is known as the derived attribute. So here in this example, student, we have one entity. It has for the start, it has 3 columns: the roll number, the name, and the birth date. And here roll number, this complete, if we draw the complete underscore line under this roll number string, so that will obviously become the primary key, and obviously roll number is a primary key for the student in the student table, so that can be drawn here. But here we can see this age column. It is a kind of dashed eclipse which is drawn as the dashed, not complete eclipse. So dashed eclipse, and the column name is age. And why it is the derived attribute? Because you can calculate someone age if you know its date of birth, right? So if I tell you my date of birth, so with the help of current date, you will be able to calculate my age. So that's why this age column is somehow completely depend on the birth date, and like not dependency. If we want, we can derive. If we don't need it, we cannot derive it, right? So that's the simple thing. But it is something, the age is something which we shouldn't like capture from the any student itself, that we tell any student that please tell your date of birth as well, and also tell your complete age as well. So if somebody tells me the date of birth, I can easily calculate the age column itself, right? So that's why it is the derived, and it is mentioned at the dashed eclipse. Now let's look at the other thing, the third part, which was related to the relationship, and we will try to look at that how relationships are defined and what is the representation for it. So representations were like one-to-one, one-to-many, many-to-one, and many-to-many. So in the ER diagram, if two tables are connected with each other, or share some sort of the relationship with each other, then that will be represented in the shape of the diamond, right? And that relationship will be written here in the diamond box, like what is the relation. And here you can see some numbers as well. So these numbers are actually representing the direction of the relationship and even the category of the relationship as well. So we will try to understand one by one. So first, relationship here, right? The diamond symbol is used to represent the relationship. So in this ER diagram, sort of very small example, here we can see one entity or table name which is teacher, and there is another table name which is student. So teacher and student are connected with this relationship, like the teacher teaches students. Okay, so that's why among them the relationship is the teachers, and that's why it is mentioned in this diamond box. Now let's look at the different categories of the relationship. So first is the one-to-one relationship. One-to-one relationship, what happens when only one instance, right? One instance means one record of an entity is associated with the relationship, then it is known as one-to-one relationship. All right. So let's take an ideal case, male, female. Okay. So female and male, we have like two categories, two entities. Female is the individual category, male is the individual category, right? And taking the concept of marriage, so female will be married to a male, right? And we are just thinking for the ideal scenario. So 1-to-1, like one female will be married to one male person, right? So that's why one-to-one relationship is mentioned. For any record which is present in the male, there will be one dedicated record for that female in the male attribute. So there will be one dedicated record for that female so there will be one direct connection of that female record within this male table as well. So that's why it is mentioned as the one-to-one mapping. Now one to many relationship, let's try to understand. When only one instance or one record of that particular entity on the left side, right, and more than one instance of any entity on the right side of the entity associates with the relationship, then this known as the one to many relationship. So again, it's very easy to understand from this diagram that if we want to design a ER model where the scientist data, right, is there. So just suppose two entities. So one entity is the scientist. This table will contain all the data related to scientists, their probably name or like their designation or something like that, right? And there will be another table which will actually contain information about the inventions, right? Every invention is unique and it will have some unique attribute to define it. So let's try to understand. So one single scientist can invent multiple things. So this relationship is quite clear, right? So even this relationship, what it mentioned, invents is a relationship, like scientist invents something, right? So and those some things will be known as the inventions. And here we can see this clear relationship as well. One like record within the scientist table is actually mapped or can be mapped with the multiple values on the invention table. So this is the concept of one to many relationship in ER diagram. Now let's look at the third thing. Many to one relationship, let's try to understand. When more than one instance or more than one record of the entity, like which is represented in the left side. So if this is the relationship, this is the left entity, this is the right entity on the left, and the only one instance of an entity on the right side, then this relationship will be known as the many to one, right? So again, let me explain with the example. So here we have a student table, we have a course table, and the relationship will be the enrollment because students will be enrolling in the different courses. All right. So now how this is many to one relationship, because let's say there are 1000 students, and let's say there will be like 300-400 who want to do the BTech, there will be 300-400 who want to do the BBA, and there are 200-300 who want to do the BCA. So BBA is one course and BCA is one course, BTech is one course, and multiple students are getting enrolled in one specific course, right? So this is many to one relationship, right? So that's how this simple it is, many to one relationship. Now let's understand the many to many relationship. So here in this many to one, if it is the M, that means on mentioned on the left side. So this is going to have the many record which will be mapped to one record of the course table. And let's talk about the many to many relationship, where more than one instance of entity which is on the left are associated with the multiple records on the right side of the entity. That means it is going to have a many to many sort of relationship. And again, let's explain it with the example. So we have a table named as the employee, we have another table named as the project. So in that case, how it is going to happen, the relationship will be assigned, right? Every employee will be assigned some sort of the projects. Okay, so again, just think from the company perspective. Means you are working in a company. So right, there will be different projects, there will be different projects, and there are different employees. So let's say me being an engineer, I can work right on project X as well, and I can work on project Y as well. Like at the same time, I can be staffed in more than two projects itself, right? So one employee is assigned to multiple projects. So this is one thing. Now similarly, within a one project, there will be multiple employees working in. So one project can be assigned to multiple employees as well. So that's how it becomes the many to many kind of relationship. Alright, so now we will look at the ER diagram sample case study, and in this case study, I will actually try to explain whatever we talked previously, right? The entities, the attributes, the relationships. So with this help of the diagram, I will explain each and everything if still there are any kind of information gap if you feel. So this is a very, very decent case study. And so this is actually, you can say, a database for a simple school or college, you can say, right? So when you think from the academic background, even in colleges, right, each college or a school will have its own website where they will be maintaining every kind of data. That data can be related to the students, courses, their teachers, and the entire admin related things, right? So lots of things needs to be managed on their end. So this is the sample case history for that one, right? So let's look at each and every entity attribute relationship one by one and try to understand how things are placed in this ER diagram. So we know, like, we will primarily focus here on the 4 key entities, right? And we'll try to understand how they are connected with each other. So first, look at the important one, the student, right? For the college, like, the most important thing would be the obviously the student's part. So student is the one entity, and let's look at the attributes it can have. So previously we studied these things, right? How to represent the attributes, those will be in the Eclipse format. How to represent the multi-valued attributes, how to actually represent the derived attributes, how to represent the key attributes, right? So for the key attribute part, if you are still confused that what is this, so in the later half of the video we will be talking about these things in depth, right? The concept of keys in the relational database management system. So don't worry about that. On a higher level, you can think or you can treat any key attribute like simple attribute or ID, right? Which is unique and uniquely identifies a record within a table, right? So let's say for our example, our Aadhaar ID. So Aadhaar ID is actually unique for every citizen of India. So like my unique Aadhaar ID will be there, and if you have the Aadhaar card, like, you will be also having a different ID for that. So Aadhaar ID is something which is unique. So similarly, there should be some attribute which can uniquely identify a record or a student. So that's the key attribute which we call. So student, it can have attributes like the student ID, first important one, and the student name here. So student name here, we can see, right? And the address attribute is also there. And this entity has other attributes like hobby, date of birth. So now address is something which is sort of multi-valued, right? Multi-valued means what we can say, it can actually have like sub attributes as well. Within the address, we can have the door, street, city, state, pin. Now underline, this attribute is mentioned with the underline. That means this is the key attribute. Now let's look at this one. This is the dashed ellipse. That means this age part is something which is the derived attribute, and I hope you guys remember why it is the derived attribute, because that can be calculated with the help of the date of birth. Now hobby is something, this is, you can say, the kind of attribute which can have like different values, like one within the one single attribute we can assign multiple, like any individual personality can have more than one hobbies, right? It's a swimming, music, singing, and multiple things. So that's how it is mentioned with the double ellipse, right? So this part is clear. And this student entity has one more attribute, which is the course ID. Okay, why course ID is actually mentioned here, I will explain it. Because for that, first we need to look at this relationship, right? So there is another entity named as the course. Course, as I already explained previously, in a college there could be courses, let's say BTech, MCA, BCA, BBA, MBA, MTech. So these are the courses, and each course will have a course ID. For MTech there will be a specific ID, for BCA there will be a specific ID. So there is another entity, course. So it has simple 2 attributes. Course ID is something which is the key attribute. That's why this underline is mentioned here. And another attribute is the course name. Okay. So what's the relation between these two? When we were talking about the different relations, one to one, one to many, many to one, many to many, there we also took this kind of example, right? How student and courses or subjects can be related with each other. So obviously the relationship between the student and course entity will be many to many, right? And that relationship we can mention like enrolls, attends, like multiple synonyms can be there for one single relationship. But this mn, right, these are the notations, like simply many to many. Even this n notation is same to m itself, right? Many to many, this denotes, right? If anything apart from the value 1, that means this is the many to many kind of relationship, because there can be 100 students who can attend the BCA course, right? And similarly, one you can say course here, like in terms of the course part, one course can be attended by the multiple students. Okay, so that's why we have the kind of this many to many kind of relationship here. And now I was talking about this course ID part as well, why this course ID is mentioned here actually. So whenever, let's say, somebody asks you to figure out that let's say Shashank is enrolled in what type of course. So if I don't have any relationship, or I don't have any mechanism to just connect student entity with the course entity, I won't be able to get that information that Shashank is enrolled in which kind of course. So that's why this is actually the concept of the keys, right? The referential keys, which we'll be studying in the later part of the session. So here, just for a like simplicity, you can treat it like a reference attribute for the course entity, which is the part of this one. Okay, so if you know the course ID, you can simply just join these two entities together and you will get that course name for sure. And whatever terminologies I'm talking about here, the joining and everything, this is the actual part of the entire relational database management system, which we'll see in the later part of the session. Now let's look at the entity lecturer. Lecturer means, you can say, your teachers, right? So lecturer, they have basically, this is also one of the entity, and it has attributes like the lecturer ID. Simply you can say a teacher ID or something, which is the key attribute, lecturer name, and also the course ID. Okay, so now let's look at the relationship first between the student and the lecturer. So here the lecturer, here the relationship between the student and lecturer is basically one to many, right? One to many. Why? Because one student can actually take lectures from multiple teachers. Like if in my course I have subjects for science, I have subjects for mathematics, I have subjects for the computer science. So I will be like guided by the 3 different teachers. That's why one student is actually mapped with multiple lecturers. So that's why this 1 to m kind of relationship, like one to many relationship, is mentioned here. And lecturer, the relationship would be like lecturer teaches students. So that is the relation which we have mentioned in the diamond box. Now let's look at the relationship between the lecture and course. That will be also one kind of the relationship between the course or something. Okay, so let's understand why there is a many to many kind of relationship. Okay, so lecturer takes course. So see, there could be multiple subjects which are somehow common between the courses itself, right? Let's say the IT management, a kind of subject which can be probably part of the BTech as well, and can be part of the BBA MBA as well. All right, so that's why one lecturer, simply you can say here, if that teacher is especially for the IT management subject, so that can actually teach that subject within the BBA MBA course as well, if it is a part of that course, and also can teach in the BTech course as well, if that IT management subject is part of the BTech course. So that's why this many to many kind of relationship is mentioned here. And similarly here, the relationship is the lecturer takes, right, which kind of course that lecturer will take. And here also the course ID is a reference mentioned here. This is the attribute which is the prime attribute of the course entity, but the reference is mentioned here, so that whenever somebody asks that this lecturer is basically teaching in what kind of courses. So you can simply join the lecturer and course entity and you will get that information. Now let's look at the last entity, which is basically the subjects. So this was the course part and the subject. So let's look at the simple relationship between these things. So lecturer and the subject relationship. So this relationship is lecturer teaches, like basically what kind of subject one particular teacher can teach, right? So that's why this relationship is named as the teaches. And the relationship would be one-to-one, because if I am a science teacher, then I will be only teaching science, right? And science is one particular, one dedicated subject. So one-to-one mapping is there. And in the subject entity, we can see we have the three attributes primarily: the lecturer ID and subject ID, something which is the key attribute for this entity, and the subject name. So lecturer ID, why it is mentioned there? So whenever we want to just get that information that science subjects is actually taught by which teacher, so lecturer ID as a reference attribute should be here, so that these two tables can be joined together and the population, the values can be populated here. And now we will look at the relationship between the course and the subjects. So course and the simple, you can say the relationship can be like something one to many, right? Because in one course there can be multiple subjects. In BTech, right, there will be multiple subjects, let's say data structures, algorithm, programming, and the cybersecurity, graph theory, and many other subjects, right? So that's why within one course, multiple subjects, and that's what the relationship has mentioned here. One course can have many subjects. So this is the overall example and a simple case study for the ER diagram, and very basic. That's why I picked the very basic simple case study, so that things are actually clear to you. And after that, you can probably pick some complex problem statements by your own and try to design a ER diagram for that. So the problem statement can be like designing the ER diagram for any e-commerce website, let's say Amazon, Flipkart, and designing the ER diagram for the library management system for the hospital, or for any kind of let's say food delivery app. So you can try to practice it. That would be a really good exercise for you. Now we will be moving on to the next part, which is actually the study of the RDBMS, like understand the relational database management systems in depth. It's all technical concepts, whatever we talked so far in the DBMS, just as a keywords. And now this is the time to explore those keywords, whatever we talked so far, and understand everything about the relational database management systems. So first thing would be, what is RDBMS? And I think whatever we have discussed so far, you have a at least decent picture to visualize what is the database management system, what it does. And most of the time we talked about the tabular or the structured form of the data, right, in the form of table, rows, and column. And that is what exactly relationship, that is exactly what the like relational database management system. Relational means something wherever you have created some sort of the data sets or kind of structured data you have, and somehow you are able to build some relationship between the tables. That will be your relational database management system. Okay, so let's understand the technical definitions first. So relational database is a type of database that stores and provide access to data points that are related to one another. That's what we talked about. Relational databases are based on the relational model. Previously, whatever we saw in the ER diagrams, how that relationship was built. In a relational database, each row in the table is a record, right? So whenever going forward, we will be using these terminologies. So one row will be like simple one record. We are trying to insert one record, deleting record, updating record, right? Now here with a unique ID called the key. So previously in the ER diagram, I was focusing on the key attribute. So in most of the tables, definitely, at least in the transactional tables, for sure, we will be having some key attributes, right? Any kind of column or the set of columns which can uniquely identify any record, right? So that is the main concept of having the key columns. And here any relation is equivalent to the table. So for the ease of the understanding, the columns of the table hold attributes of the data. So apart from the rows, there will be one more thing, which is the column. And column is nothing like simply a variable name given or assigned in the or you can say the created within the table, which will hold the values, right, for a particular thing. If it is a salary column, it will hold the values of salaries for different employees and different workers. Similarly, age column, name column. So these are the columns which are holding some sort of the data. So in the market, what kind of popular databases or basically the RDBMS are available? So the most populars are the MySQL, Oracle, and even many other organizations have created their own transactional databases. But the most popular and most common, most widely used is the MySQL, Postgres, Oracle, these kind of the transactional databases. So this is a very simple example which actually describes everything. We talked about the RDBMS. So this entire thing is nothing simple. You can say a relation or an entity or a table. And that table is actually named as the students. And this student table have these many records. So which you can see, right, this arrow or this simple line, there are different synonyms for it. We know it as a tuple. We call it as a row as well. We also call it record. And here these are the attributes, right? Attributes means the column name, and this column will actually hold some values. So these are the rows, this is our table, and the table name is students, and these are our columns, and these are our rows. So this is the very simple typical structure of the RDBMS. Now let's look at some key points for the RDBMS, like advantages of RDBMS, why they are popular, and what kind of thing they are trying to solve. So first thing is easy to manage. And why easy to manage? Because even earlier when we were talking about the databases and trying to understand the DBMS, so these are also the software application which will help any user or third party software application to interact with the data which will be stored on the physical devices, right? So easy to manage. Why? Because we can see the RDBMS are quite simple, right? In a very well structured and human readable form. You can simply retrieve the data in very easy manner, like no that much level of complexity in terms of accessing the data sets, table, or anything. That's why first thing which is popular for the RDBMS is easy to manage first. Second, the security, and you will get to know more about the security aspects when we will move, or when we will study more about the SQL and these things. So security, why it is even actually very important when we talk about the databases which are very critical. Let's say the banking data, right, which is very critical because it holds your account information, the entire amount, debit, credit related things. So it's a very critical data. So same thing happens, right, within the organizations as well. If there is any kind of data which is very important and very crucial, so you cannot allow everybody to have the access on it, right? You need to have some sort of mechanism so that you can restrict. Let's say there are 3 members in a team, only Shashank can access this kind of table, rest of the people won't be able to access it. So you need to apply those kind of access mechanism and apply those security layers, and that is actually doable, and that can be done with the help of the relational database management systems. Next, the flexible databases can easily be extended to incorporate more records, thus providing greater scalability. Also facilitates easy application of SQL queries. So flexible in terms of the scalability, right? Whenever you have a use case where you want to store some huge amount of data itself, right? Your traffic is getting increased, your data volume is getting increased. You can vertically scale your transactional databases, and even some complex concept of sharding. You can even manage your transactional databases in the horizontal scale format as well. And flexibility of accessing the data with the with the help of the SQL queries, which is in the English format, just writing or giving a one instruction or one command to your RDBMS system, and the data will be displayed on your screen in the form of the output. So that's how the RDBMS are that much flexible in terms of the access. Users, RDBMS supports client-side architectures, storing multiple users together, and that is definitely true whenever we talk about the large scale applications, right? Just think from the large scale applications like e-commerce platform, Amazon, they will be having some database in the background, and every second, every minute, there are like millions of users who have actually logged on to their Amazon e-commerce platform and making some activities, doing some transactions. So and like under the hood, obviously that database is something which is handling the real world traffic. So this is something like the RDBMS or these transactional databases somehow capable enough to allow that level of concurrency and multiple connections so that the data can be retrieved and manipulated. Easy data handling, like that's what like we were probably discussing when I talked about the SQL part, but also right when, or you can say as soon as the data volume grows, there will be some complexities as well in terms of the runtime or the execution time for the queries or the data retrieval. But also RDBMS provides some like core concepts or the optimization concepts as well, so that we can store our data in such fashion though so that it is very fast to access. So like data fetching is faster because of the relationship architecture, right? We can simply point out to any particular table attribute name and we will quickly get the data. And data redundancy or duplicacy is avoided with the concept of keys, indexes, and data normalization principles. So these are the some core concepts which RDBMS provides so that we can handle and we can like avoid such kind of anomalies. Data consistency is ensured because RDBMS is based on ACID properties. So this is also one of the core concept of RDBMS we will look at in the later part of the session. And ACID properties for data transaction, and ACID actually stands for atomicity, consistency, isolation, and durability. So we'll look at it. Fault tolerance, replication of databases provides simultaneous access like the concurrent access and multiple access, and helps the system recover in case of disasters such as power failure or sudden shutdowns. So what does this fault tolerance actually means? So the way these transactional databases work, they have the logging mechanism, right? Logging mechanism in case of the failure or any kind of like abnormal failure, they can definitely recover with the help of the kind of metadata and kind of the bin logs they have, right? So this is actually the fault tolerance part in the RDBMS. Now let's look at the important concept. I was talking about the concept of keys, and that is something kind of the backbone of entire RDBMS or the relational database management system, because tables are known as the relations, but whenever we want to whenever we want to build a solid database which are somehow connected with each other, so these key attributes are something which will play a very important role. And that's why we need to understand like what kind of keys are available and what is the meaning of each and every key. So why we need a key, first of all, let's try to understand that. And the typical reason can be like unique identification. Like in simple words, this is the actual meaning of the key attributes, right? And why it is important, again, like when you have a huge set of data and huge volume of data, and you are particularly trying to target one specific you can say record or one specific tuple, anything, you should definitely like know how you can get that data or how you can get that record uniquely. Okay, so key actually is help you to identify any row of data in a table. In a real world application, a table could contain thousands of records. That's what I was talking about. Moreover, the records could be duplicated. Duplicated means the duplication may happen multiple entries for the same record. Keys in RDBMS ensure that you can uniquely identify a table record despite these challenges. So this is the actual thing. Even though if you have the duplicate records, right, there can, let's say a table has 10-15 columns, and somehow 7 8 column values are actually matching with each other, so somehow that record is partially duplicated, and even sometimes there could be multiple duplicate entries, like every record is just matching with each other. But if we actually want to avoid those kind of things, in the RDBMS we have the integrity constraints, we have the concept of keys, which will be applied as a constraint when we will create those tables and the relation. And we are trying to, like, whenever we are trying to insert any duplicate event, that will be flagged, and that won't be entertained by the RDBMS, because we have applied that kind of integrity constraints based on the key attributes. Next, they allows you to establish a relationship. That's what in the ER diagram we saw, right? Why the course ID was available as an attribute in a student entity, because so that we can relate and we can connect those two entities whenever we want, and whenever we actually want to just relate or pull some information with these two entities, we need to know how we can just connect these two entities with each other, and that's what the referential integrity or reference kind of attributes will help. And also, like, the thing which I am talking about help you to enforce identity and integrity in the relationship. So integrity is something related to the integrity constraint, so that your data is consistent throughout the processing. Now let's look at the type of keys, what kind of keys we can have in the RDBMS. So there are typically 4 types of keys in RDBMS. First is the primary key, second is the candidate key, third is the super key, and fourth is the foreign key. Now let's try to understand each and every segment of it. So what's the primary key? So primary key in RDBMS is a column or a group of columns in a table that uniquely identify every row in that table, right? So primary key, that's why its even name is the primary or primary point of contact, or you can say a primary attribute which is responsible to provide us the like unique record from the given table, right? The primary, the properties, this is the actually very important property, and we should know what is that. So the primary key can't be duplicate, meaning the same value can't appear more than once in the table. And I gave you the simple example of the Aadhaar, right? So let's say our government of India is actually maintaining that complete database, every citizen's details, with the help of Aadhaar ID. So like, Aadhaar ID is the primary key for every citizen, right? And that is the primary key of that citizen table. And obviously, like, two Aadhaar IDs cannot be same together. And if it happens, that means a database is inconsistent, and that cannot happen. That is violating the concept of having the primary key or concept of having the Aadhaar ID, because that is something which is simply like meant to be unique, right? Every citizen is unique, their information is unique, so that's why it is important. So that's what mentioned here, like the primary keys cannot be duplicate. And also, a table cannot have more than one primary key. There could be multiple alternatives for the primary key. We will also look at what we call it, but there will be only one and only one primary key in the table. So let's look at the example here. We have the employee table, right? So whenever a new comer joins a company, right, or any person joins a company, so that guy will be assigned one unique ID, that will be the employee ID, right? So two employees cannot have the same employee ID, because in that case there will be mix up in the information of these two employees. So here, that's what even mentioned, if in the employee table we have different attributes like employee ID, employee name, address, passport number, license number, SSN, then employee ID is something which is the primary key. But after looking at these attributes, passport number, license number, SSN number, you will be confused that these are also somehow the primary keys, because they look unique. Obviously passport number will be identical, license number same, SSN. But that's what I mean, that there can be alternatives based on the use case. You can decide what kind of attribute you want to use as a primary key, but only one attribute will be treated as the primary key, not more than one. I mean, even if it is a set of the attributes, so that set of attributes is itself a one primary key. Like there could be multiple combinations with other attributes, but that won't be called as a primary key. Now let's look at the other type, that was the candidate key. Let's understand it. So a candidate key is an attribute or set of attributes which can uniquely identify a tuple. I mean, these are the key attributes. So their main role, their main responsibility is to uniquely identify a record from the table. The remaining attributes, except for primary key, are considered as a candidate key, right? So that's what I was talking about. The candidate keys are as strong as the primary key because they also help us to get the unique record from the table. Here in this table, that's previously I was mentioning, right? Employee ID was the primary key, but apart from that, we know passport number can be used as a primary key. License number can also be used as a primary key. SSN number can also be used as a primary key. So since we already made employee ID as a primary key, then rest of the attributes which can uniquely identify a record from the table will be known as the candidate key, right? So passport number, license number, SSN number will be known as the candidate key. And again, based on the use case, if you have some use case where you need to use SSN somehow, right? So you can make it a primary key because these are some alternatives for you and present as the candidate key. Now let's look at the other type. So the other important type is the super key. So super key is a set of an attribute which can uniquely identify a tuple. Again, super key is a superset of candidate key, right? Superset of candidate key because in any of the table there could be even one column which can uniquely identify a record and set of attributes which can uniquely identify a record. So the super key is actually a superset of all these kind of combination of attributes which can uniquely identify the unique record from the given table. So for example, the previous table we were looking at, the employee table. So in the employee table, employee ID comma employee name, right? The name of two employees can be the same obviously, but their employee ID can't be the same. Hence this combination can also be one of the keys, right? Employee ID comma employee name. And the super key would be employee ID, right? This one, employee ID, something which is uniquely identifying the unique record. So on a very, very higher level, think it in that perspective, what all you can say, what all attributes which are uniquely identifying a record, and even different permutation combinations of different attributes who are actually uniquely identifying a record will be known as the super keys. So that's what I have mentioned here as well. Now let's look at the last one, which is the foreign key. This is the important thing, the most important thing to build the relationship between the two entities and the two relations. Foreign keys are the column of the table which is used to point to the primary key of another table. Probably this definition might look a bit complex, but think in that perspective. So we know the primary keys, there can be one table and it has its own primary key, and there is another table, it has its own primary key. And if somehow we are making the or somehow we are placing the primary key of this table, right, as a part of the attribute of this table, so that means we have provided the reference. If you remember in the previous ER diagram, we were talking about that one, right, where the course ID was referenced as attribute in the student table. So course ID was somehow the primary key of course entity, but it is, or it will be known as the foreign key because we have the reference. So the foreign concept is applied in that way. Let's say we live in the India, and any person, right, from different country visit to our country, right, let's say from the USA and the Russia and from anywhere, right, across the globe. So we call them as a foreigner because like if any person visiting from the USA, so for that person USA is their country, right, and they are the prime citizen of that country. But if they are coming to our country, we will call them as a foreigners, right? So similarly, bringing something or pulling something as a reference in one of the table, and which is the primary key of another table, is actually known as the foreign key. And the foreign key concept is the something which creates that relation or the reference among the entities. So here we can see two simple tables, the employee and the department. In employee table, we have different kind of the attributes, and obviously every employee will be as part of some specific department. Any employee will be a part of software development department, some employee will be part of the finance department, some will be the part of HR department, right? So every employee will be assigned to some departments. And if we want to reference that one, so here we can see we will be having another department table, and department ID is the primary key of this table, and we have referenced it, or we have basically pulled this primary attribute of department table as simple attribute of the employee table, and this will be known as the foreign key, right? So this is as simple as that. I hope the primary key, super key, candidate key, foreign key concept is quite clear to you, and this is something we will keep on using in the later part of the session, where we will be looking at the SQLs or the transaction concurrencies, indexing, and many other typical concepts of the RDBMS.
Alright, so guys, now we will talk about the transactions in the relational database management system, and we will deep dive into it. We will try to understand it, because I'm pretty sure you might have heard these terminologies again and again, like let's say this kind of transaction happened in the database, then what we'll be doing, and we need to perform this transaction, insert, update, delete. So people used to refer something with the transactions, okay? And in the database management system, what is the technicality of transaction, what is the idea behind it? So now we are going to talk about that. And one thing as a disclaimer, this is the very important aspect of the RDBMS, and even you can say the entire backbone. Whole thing is actually dependent on the transaction. Whatever came, that is just something which is basically mean to work on the transactions, right? So let's look into it one by one. So first we will try to understand the technical definition of transaction, and after that we will also try to understand about the transaction with some practical examples, and if there are some core complexities, we will be having examples for that as well. So a transaction is a single logical unit of work which accesses and possibly modifies the contents of a database, okay? And I think this will be more clear if I just read this example. So this is very generic, right? Like in our real world scenarios, the best way to understand your transaction is a bank transaction. Let's say I want to transfer some money to my parents account, right, or my friend's account. So that is one transaction. Let's say I'm ordering something, right, from any e-commerce platform. Then I'm making some transaction from my wallet or from my bank. So that is some transaction where what is happening, from one side something is getting debited and other side something is getting credited, okay? And both of the parties, right, even in the beginning when we were talking about the use cases of big data, or in the beginning when we were talking about the use cases of databases, so there I explained like banking and finance sector is something where they are using the databases very extensively. And similar, whatever you are seeing nowadays on the internet, any application, Android, web app, everything is storing data and they are using the databases. So I made some transaction, so bank will deduct some amount and will update the new amount in the bank's database, right? And similarly, wherever I have sent that amount, that respective bank will just add that money in respective account and the amount will get credited, and that's how this entire flow of this transaction is happening. So this is the very practical example you can say. But in terms of the technical definition, what the transaction is, it is a very smallest unit, right? A smallest unit of execution when we talk in terms of the databases. So a smaller segment which got executed, that is known as the transaction. So here there are some simple like steps which are written here, like when a simple bank transfer or money transfer happens as a transaction, what all steps will be involved there, and that's how probably you can even understand the sequencing of transaction. So first what will happen, let's say I made that transaction, I ordered something and now I'm just paying that amount. So first whatever amount I have requested, right, okay, let's say 100 rupees I need to pay, so that read operation will happen on my account. Second step will be just deduct say I requested for 100 rupees, that 100 rupee will be detected. Third, write the remaining balance to your account, and let's say I was having 1000 rupees in my account, so after deducting 100 it will be 900. So just the deduction happen, I need to update that value on my account as well. Next, read your friend's account balance, or let's say wherever I'm transferring the money, so that amount will get read, and whatever is debited from here will be getting credited on my friend's account, and same updating the balance details something. So this is the whole process of the transaction. So this whole set of operation can be called as a transaction, although like we can say that there are multiple operations you can say which are involved here: read, write, update operation. But the transaction can have operations like read, write, insert, update, delete. So these things will be actually part of the entire transactions. So these things which are happening here, read, write, update, insert, delete, these will be the part of transaction. But this entire, from starting to the end, whatever actually happened, that was the, you can say, the logical unit, completely end-to-end logical unit which was getting processed, and that's what we call as a transaction. And these things, read, write, insert, update, delete, can be the part of any transaction. So sometimes, right, at any given point of time we might be doing like these kind of things, right, with our database. Probably we will be reading something, right, or we will be writing something, we will be inserting something, we will be updating something, and we will be deleting something. Okay, so these will be the part of the transactions. Now let's try to understand from the technology perspective or the technical perspective the different states of transactions as well. So and this state term is quite common in the software development, right? Across the software development thing, this state management, everything will be having some particular state, right? So, and if you want to understand what is the state here, so state is just nothing like, you can say, the value of something at a specific point of time. Okay, that will be actually known as a state. And so, or you can even say, let's say the progress bar. We have seen the progress bar, right? It start from the 0% till the 100%. So let's say at a specific point of time it is at the 70th percent. So I will say the current state of my progress bar is the 70%. Okay, so similarly what is happening, right? Even I will take that example again. If we are ordering something on e-commerce platform, it will have multiple steps, right? So at any specific point of time, the value of some specific record in a database can have a different state, right? Let's say you booked something, right? You ordered something, you purchased something from that e-commerce platform. So first your order will be created. So the current state of your order is created. Now after that, what will happen? The payment part, right? The payment part will happen. After that, your order will be placed. So your order, the status of your order is placed. Now after that, what will happen? Shipment. So your order has been shipped. After that, that order has been arrived at your place. And after that, if you want to, let's say, cancel or any refund related something, so this state of order record or order transaction is getting updated. So different timestamp, different state. Similarly, when a transaction happens, it actually passes through with multiple states, and those states can be actually start from here, right? So let's say as soon as I am going to do any activity on my database, that means a transaction has come into this active state, right? Active state, like where I have submitted, I written some query, right? Or I written some logic which can get or which can actually manipulate my database. So now that transaction is in active state. So from active state, it can actually go into two direction or in two states, right? Because of, let's say, manual intervention or system failure, or let's say your application got crashed. Okay, so instantly your query or whatever statement you have just thrown to your database to manipulate it will get into the failure state, right? Because it was not able to get executed instantly as soon as it was in the active state. Other state can be like let's say we were doing some read, write, insert, update, delete operation. So if there was no instant failure, it will go into this partial commit state, right? So like we will get to know more about this committing logic and why this is actually happening, because to maintain our database in the consistent state, right? In the world of technology, like any kind of failure or any kind of malfunction can happen at any point of time. So that in order to prevent this, like these kind of systems, the database management systems or any kind of application are built in such a way that even if this kind of scenarios happen, we are not losing our data, whatever we were trying to do that, right? So this is the, like you can say, before actually committing something, this is a partial commit, or you can say a checkpoint, where whatever we were trying to do, that is committed in a temporary way, right? Not the fully into the database, but in a temporary way it has been committed or it has been logged for us. Okay, so that is the partial state. And even from this partial committed state, right, because of the reasons, it can go into the failure state, right? Let's say some syntactical checks, right, failed, or some semantics check failed, or some logical check failed. Okay, so very simple operation. Let's say you were trying to do some mathematical operation which were kind of logically not possible. Let's say divide by 0. So although like when you submitted your statement, it was in active state, but when it was getting computed or trying to change something, right, it got failed because of those logical computation error. So from this partial committed state, it can go into the failed state again. Now let's say partial committed part, everything was successful here. Like your transaction got successfully executed, whatever you want to do, read, write, update, or insert anything. After that, probably you will try to commit the changes, right, or whatever was in the partially committed, because this was the temporary commit or the partial commit. Now I want to reflect, since I need to make my database consistent, or I need to permanently lock those changes in my target database. So I need to do this permanent commit, right, so that changes can happen in the target database. So here we can see this commit state, and this cycle, I hope it is clear. Active state, from the active state it can go into the fail state. Okay, and here if things were fine, it will go into the partial committed state. From the partial committed state, we will be doing a permanent commit, and that will go into the committed state, and after that it will go into this terminated state, right? That means everything was successful. After the commit, I am just terminating this transaction. So here from this failed state, right, what will happen? It will go into the aborted, because things got failed. Whatever transaction we were doing, it got failed. That means I need to abort that transaction instantly. So it will go into the abort state, and after that, from this abort state, it will go into the terminated state, right? So this rollback is, right, what is something failed, and then rollback arrow which is pointing to this aborted state. So rollback was something, let's say we updated here something. Okay, for a very simple example, again we will try to understand it with the you can say the money transfer. So let's say I made some transaction, 100 rupees were deducted from my account, and because let's say I provided wrong account information of my friend. In that case, let's say the amount which was debited, the application or the intermediate bank transfer, what it will try to credit that amount, whatever account information I have provided. But because of the misinformation, since that account doesn't exist, what my bank will do, it will just revert that thing, so that things are consistent on my database, because the success of transaction was dependent until and unless that amount is getting credited to the end or the targeted account, since that transaction wasn't complete in the middle. So the thing I was talking about, once the 100 rupees got deducted or debited from my account, it was in the partial state, right, the partially committed. Okay, I have done that, I have updated values in your account. Now I need to make the permanent changes on the target account side, and from that, because of that wrong information, it came into the failed state, right? So as soon as the failed state is updated, now this with the help of rollback, it will go into the abort state. So abort means rollback. What happened here, like whatever amount was debited, I will just again put it back, and so that the actual values are consistent, there is no inconsistency within the transaction or within the databases. Okay, and that is the actual rollback, whatever we did. Or you can even, in terms of very easy language, you can understand it like a undo operation, right? Whatever we did, just do a control Z and your previous state. So with the help of this rollback operation, we will go into the abort. That means whatever was deducted, or if anything happened on the source database, those changes will be reverted back and this transaction will be cancelled or terminated. So these are the different states of the transaction, and trust me, this is one of the important question as well from the interview perspective as well. And if you are in your colleges, when you will appear in the interviews and even your end semester exams, this is a kind of pet question, right? Like define the different states of any transaction, what will happen. So like if this is looking complex to you, right, I hope it won't, because I just explained it with the help of example. But still, the bank transaction is something which is very logical and very common to explain. You can just imagine that scenario and try to map everything with the state transitions. So these things were about the transaction states. Now let's look at this part, right? The actual part or the theoretical concept we were trying to understand. What is active state, failed, partial, and these things in the theoretical aspect. So here, if a transaction is in execution, then it is said to be in the active state. So as soon as we fired or we shared some command to our database, that means execution has started. So if anything, any statement or command is in the execution, that means it is in the active, and that will be known as the active state of the transaction. Failed state, if a transaction is executing and failure occurs, either a hardware failure, like we were talking some like your machine got crashed or anything, or a software failure, let's say your application because of the overload or multiple processing, it got hanged or something, right? So that in that cases, obviously the transaction will go into the failed state. Partially committed, as we can see in the previous diagram, right? So state from the active state when there are read and write operation present in the transaction. So whenever there will be read or write kind of statements will be present, obviously things will happen in two phases. First, partial commit will happen, and then the permanent commit will happen. A transaction contains number of read operations, write operations. Once the whole transaction is successfully executed, right? Because that one particular transaction can have multiple steps, right? So until and unless all these statements, right, within that transactions are completely successful, that will be partially committed, not the permanently committed. Okay, and the transaction goes into partial committed state where we have all the read and write operation performed on the main memory, right, local memory of the system instead of the actual database. So in whatever will be happening in the partial commit, that means those actual changes are not getting made on the target database, right? That means the execution is happening because your RDBMS is something, it is an application which has been provided to you and which is helping you to manipulate your database, right? So it has the capability to execute your transaction in such a way that, okay, we read some values, but we are not instantly going to make the changes in the target database. First, we will try to compute it wherever we are installed, and once this successful, all these statements are successful, then we will reflect those changes or commit those changes in the target database. So that is about the partial state. Again, the committed state, if a transaction completes this success full execution, then all the changes made in the local memory, like which were in the partial committed state, will be directly committed or permanently committed to the target database. Aborted state, as we have seen in the previous diagram, if a transaction fails, right, because of any reasons, right, if it fails, then it will go into the aborted state, and the aborted state means everything has been rolled back. So whatever was the previous consistent state, that will actually become the state of my database, because the current transaction got failed. So there shouldn't be any sort of inconsistency. So that was the theory about the transactions, and I hope the fundamental of transaction is at least clear, because now these terminologies will come like again and again. That's why I covered this transaction part here, so that whatever next important topics we will be discussing, you can actually understand what we were talking about and what we are trying to make you understand regarding the transactions. So next topic is the ACID property. So this is again one of the very important fundamental of the transactional databases. Now I think this is the right time as well to let you know that whatever kind of relational database management systems have, right, there actually this term is very important, the transactional databases. So transactional databases where these multiple and frequent transactions are happening, let's say the read, write, the insert, update, delete. Okay, so those will be known as the transactional databases. And there are another category of databases as well, the NoSQL databases. So in the NoSQL databases, these kind of transactions are not that frequent, right? Transactions means the insert, delete, update, right? Those are not that frequent, but because they are meant for the analytical purpose. But here these are these kind of relational database management systems are meant for the real-time processing or real-time transactions, continuously insert, update, delete, right? The CRUD operations are coming in, and that's why the continuous transactions are happening, and that's why they are even known as the transactional databases. And also for your better understanding, I would ask you to explore this terminology, OLAP and the OLTP. OLAP is basically online analytical processing, OLTP is the online transactional processing. So that concept will actually clear your thoughts about the why we call it as the transactional applications or the transactional databases, right? So now let's understand the ACID property, and as I said again, this is also very important from the interview perspective and from your college curriculum as well, from your semester exams, because this is one of the important questions in the databases as well. So so actually this ACID stands for the atomicity, like A for atomicity, C for consistency, I for isolation, D for durability. Okay, so these are the actual like meanings of this in each character within the ACID property, and everything has its own different meaning and own technical aspect to understand, and we will talk about it one by one. So first let's try to understand about the atomicity. So what is atomicity? By this we mean that either the entire transaction takes place at once or does not happen at all. So atomicity, like atom, right? Just again this atomicity came from that word itself. So something or like piece, something which is not breakable now, right? It cannot go into, like we cannot break it down further. Okay, so this is how this atomicity came into the picture. Like there will be no intermediate state of any transaction. Either that transaction will happen successfully, right, else it will be in the failed state. There is no intermediary state, because if we are focusing on this intermediate because if we are focusing on the intermediary states, that will create an inconsistency in the database, because from your source value is something else and your destination database value is something else. So again, with the help of example, let's say 100 rupees deducted from my account and updated value, let's say I had 1000 rupee, updated value in my account will be 900, but that amount has not reached to the target database or my friend's account. So obviously this is complete inconsistency, right? Because the thing we were expecting after the successful execution, that 100 amount will be get credited, and let's say my friend also was having 100 rupees in his account. So now after this transaction, on my account the remaining amount should be 900, and on his account the remaining amount should be 1100. Okay, but if the transaction failed, obviously money was debited from my account, but that is not credited in his account. So this is inconsistency, and in order to strictly apply that consistency and to maintain that kind of consistency, this is the main purpose of having the acid, or putting that kind of you can say putting that kind of rules and checks that the transaction will complete, right, either, or it won't complete. There would be no intermediate state at all. And what happens in the atomicity, it involves following two operations, so abort and commit. So these two operations will be something like which will actually guarantee this atomicity, right, or which will help this transaction to maintain this atomicity. Because abort is something, what it does, abort rollbacks everything. Like it will actually in case of the failure, what will happen, abort will roll back anything, whatever was your previous consistent state, it will put you in that state, right, if the failure happens. And the commit, what it does, it helps the database to make the changes permanent. So now even you can understand the importance of these two operations, how abort and commit operations are actually helping this database to maintain the atomicity. Now we will again try to understand that thing with the help of this simple transaction table or charting, you can say. Here again one thing, like all or nothing rule, just simple rule, thumb rule to understand the atomicity, all or nothing. Either everything will happen successfully, else nothing will happen. So here we can consider this transaction, right, the following transaction T, and it consists actually two parts like T1 and T2. So here what was happening before, this is again kind of money transfer. X was something which was having 500 rupees and Y was having 200 rupees in his account. So two different databases for X and Y, two different things. And here the transaction of 100 rupees is happening from the account X to account Y. So T1 will contain these kind of steps, and T2 will contain these kind of steps. So in T1 what will happen, first the entire value, the money value will be like read from this source account, or the account from where we need to debit the money. Then 100, just do a minus 100 because 100 amount we need to deduct, and after that whatever is the new value, because X minus 100 and again assign back to 100, so whatever is the new value, just commit it in the database, source database for the consistency part. And after this T1, what will happen, the remaining value in the account X will be 400, and if we focus on T2, so it will read the balance amount in the account Y, whatever has came from here, the 100 rupees, that means add in it and update the value of Y. So this 200 will become the 300. So if the transaction fails after the T1, because that's what T1 was something which was operating on the X account, and T2 is something, the steps which are operating on the destination account. So in case let's say T1 get failed before T2, right, this T2 is getting complete, or this T1 got failed, okay, then amount has been deducted from X but not added to Y. That's what I was explaining. This results in an inconsistent database state, because in my source database, or wherever my account is actually created, in that database this will be inconsistent entry, right, because something debited from my account but has not committed or has not credited into the destination account. Therefore the transaction must be executed in entirety in order to ensure correctness of the database state. So that was the theory behind the atomicity. Now let's look at the consistency. I think previously whatever we were talking about, you can say the example that would have definitely cleared your thought about the consistency, how this consistency part actually looks, and what is the actually meaning of consistency. So this means that integrity constraints must be maintained so that the database is consistent before and after the transaction. So whatever let's say a successful or a very like committed consistent state before any transaction, after the transaction any of the database should be in the consistent state. There shouldn't be any kind of inconsistency because of any anomaly, or because of any malfeasance, or because of any malfunction in the or because of any or because of any weird or vague behavior of the database. So consistency, what it actually refers, it refers the correctness of a database, right? So how we actually check or validate the correctness of the database, right, with the help of the data checks or the data quality or equality, whatever, let's say, previous or what will be the current consistent state in the database. So because of that comparison, we will be able to understand what is the consistency, and that equality is actually the consistency part here. If that is not getting maintained because of any reasons within the transaction, that means our database is not consistent. But in the transactional databases, RDBMS, this is something, the very important part, the consistency. Okay, and that's how probably we can look into the previous example. So here, let's say the previous example, right? So before transaction, this transaction, if we want to validate, right, total amount, so X was having 500 and Y was having 200, so total becomes the 5 plus 2, 700. Okay, that means before this transaction, the total summation of amount was 700. Now after the transaction, let's say I did any kind of the transaction, whatever, let's say debited from here and credited here. So after this transaction as well, the total amount should be equals to 700, right? If you agree with that. How that is happening? 400 plus 300, because I made a transaction of 100 rupees which got debited from here. That's why this value became 400. Earlier it was 500, and since 100 got credited here, so that's why the previous value was 200 and now it has become to the 300. So before this transaction, the total sum of money was 500 plus 200, 700, and we can see here after the transaction it is 700. That means our database is in the consistent state, right? So that is here, the consistency means the correctness. And again, if I can help you if I can help you to understand the inconsistency, let's say 100 was debited, but this T1 got failed and this T2 didn't happen. So what would have happened? Since 100 has debited from here, so this value would have become 200, but the 100 rupees didn't get credited here. So in that case, this value would have been 200 itself, not the 300. So now if we would have done the summation 400 plus 200, which will become 600, but the total sum was the 700. So 700 is not equal to 600. That means our database is not in the consistent state. Something happened with the transaction, something wrong happened, and that needs to be fixed. And that is where the atomicity helps. Like if we are not maintaining the state in such fashion, we are not doing that rollback operation, abort operation, or the commit operation, our database or values will go into the inconsistent state. Now let's look at the isolation part. So this property ensures that multiple transactions can occur concurrently without leading to the inconsistencies of the database state. So here what we actually mean here is that isolation is something, just try to understand in the simpler word. Let's say you have one single table, right? One single table, and that one single table can be accessed by different users at the time, right? Makes sense? Let's say there is user 1, he want to do or he want to read write something from the same table, and I being a different user, I can execute different commands on the same table, same database, and there is third person who is actually using the same table. So that is actually the concurrency. At the same time, multiple users are accessing the same resource or same object, same data. Okay, and now let's say they are filing their own statements. At the time, multiple statements or multiple transactions are running on the same data or same record. So with the help of the locking mechanism, which will be reading in the next part, because these RDBMS systems are smart enough to implement these kind of things or to follow these kind of properties, that's why those kind of technical implementation has been done in this system in such a way, even if the multiple transactions are trying to access the same values, same records, that won't hamper each other. Whatever, let's say they were trying to read, or whatever other different transactions were trying to read, it won't impact each other values, because this RDBMS will try to process those transactions in such a sequence that nobody's or there isn't any kind of transaction which is updating any random values, right? Let's say I given some command to my database that update the value of x, the previous value of x to x plus 10, and this guy also did same time of operation. Let's say update the previous value of x plus 30. So that is not like going to happen. I mean, at the same time, our system is not going to do it. It will do it in such a way so that everything is consistent, and those like whatever the statements and they were trying to access the same object, they are somehow not overwriting the values of each other. Okay, everything will run as a single unit. That transaction will do its own work and that transaction will do its own work. They are not getting conflicted with each other. So transaction occurs independently without any interference. Changes occurring in a particular transaction will not be visible, right? Whatever changes that transaction is going to do, it is not visible to any other transaction. That's why there is no conflict in between these two transactions. This property ensures that the execution of transaction concurrently will result in a state that is equivalent to a state achieved. These were executed seriously in some order. Okay, so because if we know the sequencing of different orders, we can even predict the output, right? Let's say I have some value x which is having the actual numeric value x equals to 100, and in sequence, let's say we are doing something, right? First there is one command which did let's say x plus 100, there is another command which did x plus 200, there is another command which did x minus 500. So this system will intelligently try to understand which transaction came first, and based on those allocation, right, based on the transaction timing and all, it will try to manipulate. That's why there won't be any kind of inconsistency again, right? If that system is actually allowing everybody to update that same value, same object at the same time, that will be an ambiguous answer, right? Everybody will see a different result. So now I will talk about the durability. So durability, what it means, this property ensures that once the transaction has completed execution, the updates and modification to the database are stored in and written to a disk, and they persist even if a system failure occurs, right? So here what actually means with the durability, like these RDBMS or transactional databases, they are again capable enough, right, that if something happens, okay, or whatever executions we are doing, first that will get computed in memory, and that will be in like two-phase commit thing, right? Like we were looking at the states of the transaction, so there was a partial committed state. So that partial committed state is nothing, it is again simply that the something got executed in memory, and after that it is just being written to the external disk or as a like temporary state or temporary committed state. And how it is actually helping, again, because RAM are something which are volatile, right? If something happens, right, because of the system crash or anything, whatever was in memory, that will be lost because your system will restart it. So that's why in the durability, it ensures that whatever has been computed, that is stored temporarily in the committed or as a committed states at some external disk, which is kind of a persistent memory. And after that, if we just restart our system back, the entire system can start from that state itself, and those permanent changes will reflect in the end database, right? So that's how this durability property works. These updates now become permanent and are stored in a non-volatile memory. The effects of the transactions thus are never lost. So durability actually helps basically in the fault tolerance, you can say as well, right? Because if there is any kind of mechanism where we are not doing this two-phase commit and anything happens in between during the execution or before just committing the changes into the databases, and if you don't know about those changes are not stored as a temporary committed state. If something happens to the database, there will be inconsistency again, because something has been read from the source database, computed, but the changes are not committed to the final database. So this durability is all about that. So the ACID property in totally, right, the main agenda or the main purpose to have these ACID properties in the transactional databases is to maintain the correctness and the consistency of the database. And I think whatever I have explained in the atomicity, so we can again just reiterate it. So atomicity is about that either everything will happen successfully or executed successfully, else nothing will happen, right? So after atomicity there will be consistency. So consistency, what it does mean, before the transaction whatever was the consistent state, after the transaction our database again should be in the consistent state, right? Now after that, the consistency part, there will be isolation. Isolation means if multiple transactions are getting executed in parallel or at the same time and pointing to the same objects, so those will be running separately. No transaction will know about each other what that transaction is trying to update, and they will run or they will executed independently, so they are not doing any interference with each other or trying to overwrite their values. Okay, and the last will be the durability. Durability is basically to provide the fault tolerance, like until and unless like our final changes are committed, those changes or the statement which has been executed, the result will be in the partial committed state, and after that it will get to the final committed state. And why that was maintained, because in between something can fail and we need to just we actually need these kind of committed state for the recovery purpose. So that is about the durability.
Alright, so now we will talk about the concurrency concept in the relational database management system. And even in the previous slides when we were talking about the ACID properties, I actually called out this term again and again. Multiple user, multiple connection, and multiple statements are getting executed on the relational database management system, and in that case this concurrency factor will come into the picture. And this is the generic one in the tech industry or in any of the application, even if you are developing software applications, Android apps, web apps, or any kind of application. So concurrency is something which you actually need to deal with it, because in today's modern tech industry we are trying to write the scalable applications. So scalability means at any point of time there can be more than n number of connections at the same time on any application. So your application should be capable enough to serve those multiple concurrent requests, and same goes with the RDBMS as well, because that is also one of the software applications. So at a single time there can be n number of connections, n number of statements can be executed on the database. And when this actually happens, so those concurrent connections or those concurrent statements sometimes might try to access the same table, same sort of record, and that may actually lead to ambiguous results if the sequencing is not maintained properly, right? So this concurrency concept is all about that. So let's deep dive into it and understand its different technical aspects. So in a multi-programming environment where multiple transactions can be executed simultaneously, it is highly important to control the concurrency of transactions, because it can lead us to the ambiguous results, right? There some, let's say transaction 1, or let's say there is transaction 2, they are trying to access the same object, trying to modify the same object, and there is no proper sequencing is maintained. They may override values written by each other. So we have a concurrency control protocol to ensure the atomicity, isolation, and serializability of concurrent transactions. So these things are actually maintained by the RDBMS system itself. So that is the inbuilt feature of them, the way they have been designed. So they actually take care of these things in its core. So concurrency protocol can be broadly divided into two categories. So since here we saw, right, the concurrency control protocols, so there could be multiple ways to handle the concurrency, right? And here in the databases we have the two methodologies, you can say two protocols or two set of instructions we use to follow in order to maintain the concurrency. First type is the lock based protocols, and second is the timestamp based protocols. So let's try to understand both of them one by one. So in log based protocols, what happens? Database system equipped with log based protocols use a mechanism by which any transaction cannot read or write data until it acquires an appropriate lock on it. So let me explain what actually mean. So this locking system or the log based protocol is very common, right? Very general in nature as well, right? Even we used to put a lock if there is some data, right, and we don't want anybody to access it. Just we put a lock in it, and until unless, let's say we are come let's say we are came back, and then we hand over the key to someone else, and then they can access it, right? And similarly in like the real world, whenever you see, right, there can be multiple scenarios where you are actually not allowed to access something until somebody else has executed it, or somebody else has used it properly, right? So this is nothing, basically the resource consumption and proper allocation of resources based on the sequencing and even to maintain the concurrency part. So in log based, what happens if there are multiple transactions which are getting executed? So here what will happen, any particular transaction won't be able to execute anything on particular table, particular record, until and unless it will require some lock. So if you want to execute something, first lock that object, whatever you want to compute. It can be a table, record, whatever it is. Just first make sure that you have requested properly and you have got the lock on that particular table, because until unless you won't get the lock, like we won't be able to execute anything, right? Because that locking itself means that somebody else is using it, right? So I will be waiting for that lock to be unlocked so that I can consume that resource. So here even the locking is actually two types: binary locks and the shared or slash, you can say, the exclusive locks. So in binary locks, what happen, a lock on a data item can be in two states. It is either locked or unlocked. So this is very straightforward. Binary means either it will be locked, completely locked. That means, let's say 5 transactions, right, simultaneously, concurrently, they are trying to access same table, and based on let's say different intervals, they came into the system. So whosoever got the log first, let's say T2 got the log first, so it will just access that object and it will keep on executing whatever execution or whatever computation it was supposed to do. And once that is done successfully, gracefully, T2 will unlock that table, that I have completed my task, now I can unlock it, and other like remaining transaction T1, T3, T4, T5 can use it. So here, like, no sharing in between. Okay, let's say partially I am doing my task, partially you can do your task on the same object. No, if somebody has logged it, it is completely blocked until unless that person or that transaction release it. So this is the purpose of the binary locks. Second is the shared or the exclusive locks. So even this shared term itself represents what is the meaning of the sharing based lock protocol. So this type of locking mechanism differentiates the lock based on their uses. If a lock is acquired on a data item to perform a write operation, it is an exclusive lock. Allowing more than one transaction to write on the same data item would lead the database into an inconsistent state. Read locks are shared because no data value is being changed. All right. So here, why shared and exclusive? So these two terms added here itself, like a lock can be exclusive and a lock can be shared as well. So let's say 10 transaction came into the picture. Okay, and they somehow actually let's say 5 of them are just doing the read operation from table X, and 5 of them are actually trying to do the write operation on that same table. Okay, so whatever transactions, like, they are trying to access the same table and same set of records and trying to modify it, that in that case lock will be exclusive for those 5 transactions who are here to update some value or to write something, because writing is something a very critical operation. It is modifying the state of database, it is updating some value. So again, that's what I was saying, it will lead us towards the inconsistency in the databases if we are not managing the concurrent write request on our database. So that's why when write request is there, definitely like lock will be exclusive. It will be a very straightforward. If let's say T3 has locked the table for its write operation, once it will be done, then it will be released, then other T4, T5, T6 will be able to consume it. But this is not the case with the read operation, because read is something which is very straightforward. So read, let's say there is a book, right? There in the book, it is a book of science, something, right? Same author, same subject, and anything. So like I can read that book, my friend can read that book, and me and my friend can together read that book, because here what is happening, we are not going to modify anything in that book. That book is a common resource for us. We are consuming something, right? The value or the content which is written in the book, that is not going to modify it at all. We like manually, we are not modifying it like in any way. So that book is actually a common resource for us. So similarly, if within a table there is some information which can be consumed by multiple operations and multiple transaction, so there is no harm to make that table as a shared table for those transactions who are actually doing the read operation. And that's the purpose of, or that's the main motto behind the shared locking. So I hope you get the difference, the exclusive and the shared and the binary type of locks. Now this was about the lock based protocols. Now let's look at how this timestamp based protocol works and helps in the concurrency part. So time based protocols, the most commonly used concurrency protocol is the timestamp based. This protocol uses either system time or the logical counter as a timestamp. So I hope somehow with the timestamp based name, right, you might be getting the idea of this protocol and just apply it in your general life as well, right? Let's say you are going to the railway station, right, for the train reservation or anything, right? Like physically, you just are going there and want to book a ticket. So obviously there will be a queue. In that queue, how they actually figure out who is actually eligible to get that ticket first, or second, third, and so on, based on the time value. Let's say I arrived station at 10 a.m. and somebody is coming at 10:05. So obviously I am someone who is or who should be on the priority to get that ticket, right? And that is the timing part. So similarly, like even that databases or the RDBMS system applications are smart enough. So as soon as there will be some transaction or any incoming traffic of statements will be coming, they can use the system time and even any logical counter as a timestamp, right? In order to just figure out, okay, who came first and who came next, something like that. So this is the first point. Second, lock-based protocols manage the order between the conflicting pair among transaction at the time of execution. So at the time of execution, like this is the theory about the log-based protocols. So how they actually work, at the time of execution, they will figure out, okay, whether do I need to just log this table for transaction T, T3, T4, T5, because at the time of actual execution, our DBMS will be able to know that yes, there are 5 transactions which are here to do the write operation. Okay, so in that case, obviously in the log based protocol, the actual decision is being made during the execution of statements, whereas time based protocols start working as soon as transaction is created. So here there is nothing like that, means somebody will wait until you start your execution and at that time I will figure out whether I should provide you the lock or not. In timestamp, whosoever is coming first, let's process it. That's simple as the definition is. So every transaction has a timestamp associated with it, and the ordering is determined by the age of the transaction. Age of the transaction means how old it is and how new it is. So that is the age factor. Means a transaction created at, let's say, 2 o'clock time would be older than all transactions that come after it. Like that's obvious. Let's say I am someone who came at the 10 a.m., right? And somebody came at the 10:20 a.m., then 10:30 a.m. So I am in a kind of transaction which is older than those two who came after me, right? For example, any transaction Y entering the system at 4 is 2 seconds younger, the priority would be given to the older one. So this is like the at the second this transaction came into the system, and at the fourth second this transaction came into the system, right? So who will be given the priority? Obviously this one, because this was the older one. In addition, every data item is given the latest read and write timestamp. This lets the system know when the last read and write operation was performed on the data item. So even like the database, when it will use this timestamp based protocol, so these timestamp related values will be managed by the database itself, like when the latest read or write operation happened on the table, even if a transaction is coming into the system, then what was the time for that transaction, and based on those time sequencing ages it will maintain that sequencing. And since sequencing is maintained property since sequencing is maintained here properly, there won't be any chances for any inconsistent state or any sort of stuff, because like the proper sequence has been made here and everybody is getting time for their execution, not like all 5 or 6 transaction at the same time at the same second pointing to the same object, because obviously it's quite normal there will be some at least a millisecond sort of difference in the arrival of different transaction, and even based on that millisecond of the time interval, the DBMS can decide who should be given the first priority and who should be the next one. So that was the main concept about the concurrency in the DBMS. So these two kind of protocols are basically used, and even the important factor in the databases and in the journal applications as well. Now comes to the main part, and one of the most important concept in the DBMS as well, most important concept from the interview perspective as well, and most important concept in terms of the database optimization or the query optimization perspective, right? So we will look at the indexing and we will try to understand why it is that important, what's the main purpose to have it. One by one we will discuss it. So first let's start with this, try to understand what indexing is. And I think this is very common, and indexing in general, right, we can even understand the value of the indexing just with the help of our books, right? If we have a 500, 600 or 1000 pages of book, how can I precisely find a particular chapter and how can I actually read it? So obviously the thing which actually helps us, the index page, because in index page the subject title or the topic title, even subtopics, right, will be mentioned, and those subtopics are on which page index, and we quickly just find it out. So same concept works in the databases as well, transactional databases as well. And I will tell you that how this actually works and what's the typical meaning of it. So indexing is nothing, just a kind of data structure technique to effectively retrieve records from the database files based on some attributes on which the indexing has been done. So again, simply you can, in order to understand the indexing, just keep this example in your mind, the index of your book, right? So the way the index page of your book actually helps to quickly retrieve or to quickly jump onto that particular page. So similar concept has inherited from that concept. In our databases, in particular table, it can have like very huge amount of data. It can have, let's say, 1 million, 2 million, 10 million kind of records. Okay. And whenever we actually operate on these tables or on these kind of database system, we will be working on some specific set of records, and in order to work on those some specific set of records, we need to actually just try to find it where they are located in the physical memory. Okay, we, as based on the statement which has been received by the database, it will quickly check, okay, which table it is, what kind of column is being accessed in that query, and the internal pointer or the internal head pointer of the system will just locate that record wherever it is stored in the physical memory, and then we'll be able to retrieve it. So there is too much like you can say seek time involved here, right, if we are not including this indexing concept. So because that could be a potential question as well, like why do we even need the indexing? So in order to understand the indexing, we need to understand this concept as well, like how this simple record like storage and record retrieval works. And everything is data here, so that will be stored in the memory. So just you can relate with your simple programming languages where you have some variables and you assign some values, so those values will get stored some memory location. And same happens with the databases as well. Whatever table we have created, whatever data we are giving it to the database, that will be stored to some particular memory location. And if we quickly, when we talk about these number of records like 1 million, 2 million, 10 million, that seek time can be really big, right? And it will result the slow query performance. Let's say we fired a statement, right, and after 5 minutes we will be getting the result because the data volume was big. And there should be some mechanism so that we can quickly find that particular record which we want. So here this indexing will help into the picture. And similarly, it is just a kind of data structure, you can say a custom data structure for you, which will hold the actual memory locations, right, the actual memory locations of those records which are stored in the databases, or eventually you can say in the physical memory. And since you have the memory location of those actual records, you can directly jump there and pick that record. So retrieval would be really fast if you have applied the indexing. And even the indexing part is something which works on based on the column concept, right? Because there will be some specific column which we will be using again and again in our queries. And when this thing actually comes into the picture, like repetitive columns or any logical thing which you particularly think that should be used as the indexed column, we can use it. And based on that indexed column, the actual memory locations will be saved here, right? So that is the whole concept of indexing. And there are different types of indexing as well. And now we will talk about it one by one, right? How these different indexing actually looks and what's the advantages of it. So first is the primary index, second is the secondary indexing, third is the clustering indexing. So in primary indexing, what happens? Primary index is defined on an ordered data file. Ordered data file, nothing like again a structured data. It will have some set of rows, columns, okay? The data file is ordered on the key field. The key field is generally the primary key of the relation, right? So when we can say that we have applied the primary indexing, so if we have used the primary key as a column where or using which we have applied the indexing, that means this is the primary indexing. So here, because primary key is something, right, which will be unique, as we know from the previous concept, that will be unique throughout the table, because this is the primary key. And obviously it will have some ordering as well, some specific or sequential ordering as well. So as soon as we apply this primary, or if we actually use the primary key in order to create the indexing, so those records will get ordered in that fashion. And as soon as that index part is actually present with us, we can quickly just point out to those records for which or basically you can say which are actually mapped with the help of these primary keys, we can quickly retrieve it. So again, like to just reiterate, this indexing is just nothing. Again, you can see like a simple table has been created for you, right, where like you can have multiple columns. Multiple columns will be something like the columns you have chosen for the indexing, and those columns are actually where they are located, like the values where they are located, okay? And that will be your you can say memory address of those record itself. So secondary indexing, secondary index may be generated from a field which is a candidate key. So if you remember the previous topics where we talked about the key concept, so candidate key is something which is then the alternative of any primary key, because those candidate key will eventually return us the unique record, or basically these candidate keys are also something which uniquely identifies a record from the given table. So if we are using the candidate keys in order to do the indexing based, or you can say the we are doing the indexing based on the candidate keys, that means that is a type of the secondary indexing. Now let's look at the clustering indexing. So clustering indexing is defined as an ordered data file. The data file is ordered on a non-key field. So whenever we are actually trying to do the indexing on non-key attributes, that means that will fall into this cluster indexing. So clustering actually means, right, so like let's say we have our data for the populations, right? We have the data for the population of different countries. So here what will happen, in that particular table there will be one non-key attribute, let's say country name. So India, let's say China, USA, and there will be England, or anything, right? So there will be country names for the same. And what will happen, uh, within that table for country India, there will be multiple entries, right? Now if we know that somehow I pick this value India, I can make a cluster of it, like whatever records where this value is at the country value, or the country name value is equals to India, that is a separate part itself. So whenever, let's say, I want to compute anything within the population of India, I can quickly use that column name where the column name is equals to India. And if I exactly know where all the records related to country name India are stored, I can quickly go there and use that part. There is no need to unnecessarily scan the entire table where we have the mixed records of the India different countries, because that will be unnecessary traversal time. It will even increase your seek time, because you are unnecessarily scanning the table, although you actually need the data set or the cluster of that particular data which is especially meant for the India, right? So that's how, like, sometimes those kind of non-key attributes can help us in order to create the indexing in such a way. Now within the primary indexing, it is actually of two types. So first is actually the dense index and second is the sparse index. Let's look at it. So what happens in the dense index? In dense index, there is an index record for every search key value in the database. This makes searching faster but requires more space to store index record itself. Index records contain search key value and pointer to the actual record on the disk. So that's what I was saying, right? So when we are actually trying to create the simple indexing kind of small table, or basically a kind of small table, or you can say it's a data structure, somehow it will hold that column values, right, for which we have applied the indexing, and correspondingly it will hold the memory location where we can find that record, or where we can find the record where if we apply the search key is this, right? Let's say search key India, so in front of it, it will have some memory location and it will directly point to there, and then after that our seek pointer can read all those records related to India quickly from there. So in the dense index, what actually happened, so here this index will be created for every column value, right? So if let's say we had that country name column and we have, let's say, more than 30 or 40 50 countries something, right, values, so there will be one entry in the indexing table for each column value. So for India there will be one entry, like the value is India and its corresponding memory location. Similarly for the China, for the USA, for the United Kingdom, for the Russia, and many others. So for every single distinct value, there will be one entry in the indexing table, so that we can quickly jump there. So that's why it will become quite dense, right? Because there are so many values and we have accommodated everything. And that's why it will be known as the dense indexing. So dense indexing is definitely beneficial because for everything you have a mapping available. You can directly jump quickly on that particular memory location and pick the record, but it will definitely eat up the space as well, because indexing, like when we talked about the data structure, so somehow like you are holding, or you are like creating a kind of or you are somehow actually occupying the space in the memory itself in order to create these entries. Okay, for India this will be the memory location, for USA this will be the memory location. So that also needs some space, and you have, let's say, somehow picked that particular column which has so many distinct values, right? Let's say you have in your target table you have more than 10 million records, and you picked that particular index column, right, which is having even, let's say, 1 million kind of distinct values. All right, and you did a indexing on it. So that will also like take up a good memory storage, right? Because in order to hold those 1 million distinct mappings for the memory locations is something which can take a good amount of space. So that is the main thing. Although it will be dense, it will help us in the quick search, but from the space consumption perspective, it is not that efficient. Now let's talk about the sparse index. In sparse index, index records are not created for every search key. An index record here contains a search key and an actual pointer to the data on the disk. To search a record, we first proceed by index record and reach the actual location of the data. If the data we are looking for is not where we directly reach for the following index, then system starts sequential search until the desired data is found. So now what actually mean here? So here you can see, right, the all the mappings has been created here. So in sparse matrix, right, our database will smartly it will not try to create the index entry for every distinct value, or the search key, you can say. Whenever I'm saying distinct value, for the search key, right, here India is a search key, like, or you can say value for some specific search, and Japan for some specific search value, and Germany and France. So what it will do, it won't create the entry for every distinct kind of you can say the entry which is present, right, in the particular table. What it will do, it will just pick some of the distinct values, right, some of the distinct values, and it will make an entry for that. As simple as that, it will make an entry for that. Cool. So in that case, what will actually happen? So if we also know, so indexing is something which will be again in the order. Even let's say you can see, right, whatever we have here, right, this will be, these search keys will be some in some specific order, right? So in some specific order, what will happen here, you can see wherever we have these arrows, right? So that means index has been created for India, right? As soon as we have this value India as a search key, and in the index table, obviously the entry has been made, we know the direct memory location of this record. I can quickly jump there. For Japan, we have the direct mapping in the, or the direct entry in the indexing table, but here again for the France we have the direct indexing, but for Germany we don't have the direct indexing. So in that case, what will actually happen, if you again read this statement, to search a record we first proceed by index record, right? First index record and reach at the actual location of the data. If the data we are looking for is not where we directly reach by following the index, then the system starts sequential search until the desired data is found. So in that case, what will happen? First, it will see, right, whatever the column or value or the search value we are trying to find, if that is somehow present in the indexing list. Okay, so based on that, directly we can jump onto that location, right? We will get the particular record. So here, let's say we wanted to search a record, or we wanted to pull a record for the country Germany. So here you can see for Germany there is no direct index entry has been made in the indexing table. So first, as soon as we pass this request, the pointer will come here. It will check, okay, if that value or the search key present here. If yes, I can quickly jump onto that memory location. If not, what will happen? It will try to do the sequential searching, right? Sequential searching until and unless it will find the record. So it will check if, okay, the current search key is equals to Germany, and if I'm pointing to this record, here India not equals to Germany, here Japan not equals to Germany, but here Germany is equals to Germany. That means this record will be just thrown back to the input request. So that's how this sparse indexing work. And here you can see, since like entry was not made for every single you can say the distinct value, that's why it won't take that much space. Few of the distinct values will be picked, and that's how the indexing will be created. Now let's look at the secondary index, what happens in the secondary index, and we will try to understand it. Okay, so in secondary indexing, to reduce the size, so why we are again focusing the size, that is the important perspective as well, from the memory efficiency and from even the optimization perspective. If we are not like smartly taking care of these things, our applications or may get crashed, and because of that heavy load on the databases, and even our database won't be able to scale because there is unnecessary memory is getting occupied. So in secondary index, to reduce the size of mapping, or basically you can say the indexing table, another level of indexing is stored, or another level of indexing is introduced. In this method, the huge range for the columns is selected initially so that the mapping size of the first level becomes small. Then each range is further divided into the smaller ranges. Okay, so here in this diagram you can see, right, this is the data block, you can say, in memory, or you can say this record. This is record 1, which is stored at memory location 100. This is record 2, which is stored at memory location 101, and similarly, right? Now here we can say, first we have created this indexing table. In this indexing table, what happened, we actually just pick this entry, right? Let's say if we have or we basically want to find here this 100 was actually meaning some column value, let's say the roll number, right? Roll number of any student. So roll number 100 is stored in this memory location, roll number 101 is stored in this location, this and so on. So here first on the, like what we did, we created one mapping table, or again a kind of indexing table, first level of indexing table. What it will do, it will use this roll number as a search key, and for this one it will create one entry, okay, where this record for the roll number 100 is stored. So again things will be in some specific order, like ordering will be maintained. Okay, so here you can see, right, it has this entry has only stored the memory location of this record or this block, and this one, like the roll number 10, the second entry in this indexing table is for the roll number 110. So the entry for these one, because else it will become quite dense, right? So this first level of indexing is somehow the good example of sparse indexing as well, because if we know somehow we can reach here, and from there we can sequentially somehow just reach at a specific record. So how, let's say I want to search a record for that student whose roll number is equals to 105. So quickly from here to here, right, roll number 1, and I know roll number 105 will somehow lie between these two roll numbers. Okay, and 105 is something which is less than 110. So I should quickly pick this record, and I need to reach the memory location for this roll number 100, and from there I can quickly start, and I can simply reach to 105 and will pick that one. Same goes for the other example. So this is the first level of indexing we have maintained. Now similarly, we can actually somehow disperse, or we can bypass our incoming request for the filtering or record searching. How? Again, based on this ordering and indexing, right, we can even minimize the scanning of the data. So here, this is the first level of the indexing will be created. This index will be created in the main memory, because whenever we perform the indexing, or whenever we try to create the indexing, that indexing is something that will be stored in the in memory, the RAM part, right? That's why this search query becomes very faster, because as soon as there is a search query, we will quickly go into the indexing which is stored in the main memory, and will quickly directly refer to that particular record. So here the first level of indexing has been done, because it will be quite big in size, here we have took some smaller gaps, okay, and created the entry based on that, and that's how that will be stored in the secondary, right? You can say your external hard disk, not external means the other one, like the which is in your system itself, right? The external hard disk part. So this one will be created here. And now somehow if we the concept we followed here, same concept we follow here we have increased the gap, right? From here we are not again storing entry for everything. We made an entry for roll number 100, we made an entry for roll number 200, we made an entry for the roll number 300. And now this index table or this indexing table will be in the main memory. Now let's say there is an incoming request where we are trying to filter out the record, or we are trying to find the record for the student number 209, right? Roll number 209. So what will happen? So that request will first try to check, okay, if the index request has been like maintained in this indexing table, right? So how can I actually pull that record quickly? So I can somehow find the memory location of that record and quickly retrieve it. So it will come here, it will check the record or the roll number value is 209, which is greater than the 200. And we also have a value or memory location stored for the roll number 200. Now the next one is the 300. So roll number 209 is something which lies between these two, right? And with this entry, or with the help of this entry, I know the exact memory location for the roll number 200. So I will quickly jump here, because this memory location is pointing the memory location of this record, which is maintained in the secondary memory. Okay, so step by step we are going. So now I am here, and here I know what is the memory location for the like roll number, or for the student whose roll number is 200, or what is the actual memory, the physical memory where that data is stored. So I can quickly jump here with this arrow. I will be quickly jumping here. Now I know I need to pull the 209th record. So sequentially I can come here 201, 202, 3 something something, and then we will reach to the 209. So you can see, right, how smartly our database ignored these unnecessary like scanning of the records. It quickly first checked here, right? Then it directly jumped here. It avoided these many scans, and then it quickly jumped here and pulled that record. So somehow with the help of this indexing, or the two level or the secondary level of indexing, it avoided these many scannings or these many records, and directly jumped to the roll number 209, and that's how our retrieval also became quite fast here. Now let's look at the last one, the clustering indexing, how it actually works. So sometimes the index is created on non-primary key column, which might not be unique for each record. In such situation, you can group two or more columns to get unique values and create an index, which is called the clustered index. This also helps you to identify the record faster. So here in the previous slides, when I was talking about the clustering, there can be non key attributes as well, on which we can apply the indexing as well, and that's how like they can eventually help us, right, to directly point onto that specific chunk. And as soon as we just jump there, or we moved there, or basically that kind of cluster, we can somehow like apply another kind of indexing there, right? If that those even data volumes are quite small. If not, we can somehow just directly do the sequential searching from there. So here in this clustering index, you can see we have a table for a company where different departments, right? And in different departments there will be different employees working in. So now we at any specific point of time, if we want to point out, or we want to pull the record for the department where basically, or that particular employees is working in department number 4, right? And department is something, department name, you can say basically something which is like non primary key attribute in the employee tables, right? Because that will be duplicated entry. There are 100 employees, so out of 100 there will be, let's say, 30 employees who are working for the, let's say, software department. So that software department value will be repeated 30 times. So software or the department name is not a kind of column or the key attribute column which we can use. It will be a non-peak like it will be a non-primary key kind of attribute. So on that, here you can see, right, for all the records where the department is something like that, right, where the department ID, let's say 1 2 3 4, so I have stored the pointer value for that, right? So you can see this cluster, right? Clustering means this piece of memory locations is something or is basically ordered in such a way these are like somehow giving all the values or all the records for the employees who are working in the department 1. That's why I have only stored the starting location or the starting address of this entire set of memory blocks, because somehow if I'm able to read or reach at this starting address of the first record itself of the department 1, I can sequentially iterate here and pick any specific employee ID or employee record here. So similarly, this value is pointing to this one, right? These memory blocks, and this is the starting address, or you can say if this is the collection of memory blocks for the department or basically for the employee records where the department ID is 3. So that entry is made in this cluster index table, similarly for 4 and similarly for 5. So here you can see that that cluster was made, whatever we have just divided the chunks and we are just pointing that chunk. Within that chunk we are trying to find some records. So that was the concept of indexing, and I must say this is very, very important from the optimization perspective, the query optimization. Now even you understand how those unnecessary scans were avoided with the help of the proper indexing. And this is why this is the very, very important concept as well to understand in order to create the optimized application, even in order to perform the optimized queries and other kind of stuff. So make sure to read these things carefully from the interview perspective, from your technical understanding perspective. These are really important. Now we will look at the most important part of the DBMS, or even you can say the databases, like how to execute statements, how to write such kind of statements which will somehow manipulate the data which is stored in the databases, how to retrieve the result, how to write those kind of operation. So let's take again the simple example of the programming languages. So every programming language has its own type of syntax, like its way of declaring the variables, way of writing the for loops, if else condition, and many other things, right? So similarly, when it comes to the databases and when we want to interact with the databases and want to manipulate or anything, any operations like that, we also need to follow some specific rules or some specific syntax, right? And that syntax is something which is called as a SQL, or you can say structured query language. So this is basically a set of you can say operations or a proper syntax or a kind of, you can say, programming language in order to just query some data or to just retrieve or manipulate some data stored in the databases. So whatever steps or whatever statements we write, right, those executable statements in databases, those statements will be known as the queries. So we are just firing a query and we are sending a query. That query will be nothing, a set of instruction we will write. Okay, this column needs to be picked, this table we need to point, and these kind of aggregation, these kind of filtering operation we need to do, and that entire set, right, whatever we have written, that will be sent to the database and it will get computed. So that's why the SQL is obviously one of the most important part. I mean, whenever we are, let's say, working in any of the applications, software applications, obviously there will be obviously we need to interact with the databases. So if you, let's say you are a web developer or any Android developer, iOS developer, and majorly let's say you're working on the backend part, so you might be writing some REST APIs, okay, and those REST APIs somehow will make some DB calls, and that DB call might be firing one of the SQL queries, right, to, let's say, get the user data or to get the updated amount or to update something, write something and read something, right, and return that output to the front end part, right? So this is one aspect, but in the world of big data, right, when we talked about the data analytics and anything, so that is heavily dependent on the SQL, because this is something which will help us to manipulate the data. Whatever raw data is stored on the database side, we can write our own logics, business rules using this SQL, right, in order to calculate some insightful matrices, in order to create some insightful or to bring meaningful output data from the databases. So in the big data profiles, this SQL is very important and has a very big advantage, and you can say a very big weightage in the interviews as well. So 30-40% of your section in the interviews will be dependent on your SQL, so you have to be really good at it. But since this entire session is all about the DBMS, so we won't be deep diving into the very core part of the SQL, but to just give you a glimpse how SQL works with the DBMS and what are the basic operations here, I will talk about that. And for the dedicated SQL, we have already created some videos. You can check out our previous videos, like dedicated lecture for that as well. But here we will talk about the basics only, very basic things, right? How different commands are segregated in different categories. And apart from that, since this is something which cannot be like elaborate in terms of the theoretical aspect, so I will also demonstrate some of the important, right, and some of the basic commands with the help of live demo, right? I will type some commands and will even show you on the screen that how these commands are working, what's the database create, and these kind of simple queries. So first let's look at what are the important commands we have, the different categories. Let's understand that, and then I'll show the practical part. So SQL stands for Structured Query Language. It is used for storing and managing data in RDBMS. So basically this will help, this syntax, this because SQL will also have its own syntax, in own way of writing the things, so we need to follow it in order to interact with any RDBMS. It is a standard language for RDBMS. It enables a user to create, read, update and delete relational databases and tables. So we will have some kind of database where we are storing some data, and that data will eventually stored in some tables. So with these SQL commands, we can manipulate any data stored in any database and any table. All RDBMS, most of the like popular relational database management systems are known as so most popular, right, which one is used is the MySQL, Informix, Oracle is there, MS Access and SQL Server, right? So these type of actually like relational databases which are in the market, they actually use the SQL in order to interact with it. SQL allows user to query the database in number of ways using like English like statements. So same happens in the programming as well, right? In programming, we whatever that is a very high level, like we have Python, Java, Scala, right, other languages. So those are the high level languages where everything, whatever instructions we are typing, it's a pure English type of language, and we just type and that gets executed. So same happens with the SQL as well. So within the SQL, there are different commands, right? And those commands are actually divided into few categories. So let's understand what each category means and why that command is like has maintained in that category. So DDL first is category is the DDL, data definition language. So again, I'll take the example of programming. So when we want to execute something, right, we will need some inputs and we will need some output. And in order to store that or read that input and output, we need some variables. So whenever we start writing some program, so obviously in the beginning we will declare some variables, right? We will define those variables. Some of the variables will work as a input. They will, whatever user is sending us, that input will be stored in those variables, and there will be other variables where we are computing something and storing the output in it, and those variables will be known as the output variables. So similarly, we know in the relational database management system, we will have the databases, and within the databases, we will have the tables, right? So these tables also contain some of the columns, let's say name, salary, date of birth, right? Multiple type of columns they can contain, and each type of column will have its own type. Let's say name is something which will be of a string type, date of birth is something which will be of date type, salary is something which can be the float or the integer type. So here obviously before like working anything or before moving into the data storage part in any of the table, first we need to create it, right? We need to define it, we need to define this. That is why that is named as the data definition language. So any SQL command which is somehow impacting the structure or which is somehow modifying the structure of existing table, right, or a table which is going to be created, that sort of command will fall in this category, DDL, right? So what typical type of commands, SQL commands we have in the RDBMS which can fall into this category? So create command, very simple to understand, that we are creating some table, right? So that means creating, that is a new structure we are building for any table, that is one thing. Drop command will be something, it will delete the entire table and its structure as well. Okay, so that means we again modified the structure of given table, we just like played around the structure of any given table. So that's why this is also in the DDL. Alter command is something that will be in or that can be used in order to just change the structure of any existing table, right? Let's say earlier you had 4 columns in your table, now you want to add one more column. Okay, so you need to run this alter command, and that's why, that means you added or you actually changed the structure of existing table by adding one more column. Similarly, let's say there was one column, salary, and earlier its data type was the float or kind of double, okay, which was even having the fractional values. Now we want to convert it into the integer type, right? So in that case, what we are going to do, we are going to change the data type of existing column. So this is also the change in the table structure. So that's why these are the commands which will be in the data definition language. Now DML is basically data manipulation language. That means there could be or there will be some commands which will help us in order to manipulate the data. Manipulation can be of anything, even we are trying to just do the read operation and write operation. Okay, so those kind of things will be in this, or those kind of commands will fall in this DML part, right? So what are the some simple ones here? The most often used, the insert. So insert command is something where we want to insert one specific record, right? Because a table will have some columns, and in the table we store the data in row and column wise. So whenever we want to insert one row complete record into the database, or basically a table within a database, that means we need to use this insert command. Then there can be update command as well. Update, let's say there was some specific row, and that row can be identified with the help of primary keys, right? And candidate keys, composite keys, right? Many other things we can use so that we can uniquely identify one record. So for example, now we have a employee table, and that in that employee table we will have the employee ID, employee name, salary, and its department. Okay, and since it's an employee table, every employee will have its own employee ID, which is the actually primary key, right, in this employee table. Now let's say there is employee whose name is X and his employee ID is 1. And what we want earlier, let's say that employee was working in the IT department. Now we want to move into the software department. Okay, so what will happen? The earlier or the previous entry which was present in that employee table for the employee X and its department was IT. Now we need to update that value. Hope you are getting my point. Since we need to update that value, so updation means what we will do first, we will just point out to that record where employee ID is 1, right, or where the employee ID name equals to X. Okay, and just update the value of the department column for that specific record only. So here we are doing the manipulation again. Third can be the delete, right? So here delete means we are deleting the records which are present in the table, right, that based on any kind of business logic or business rule. Let's say we have the data of the employee tables, and it contains the data for all the departments. And from this table, what we want to remove the records of all those employees which belongs to some department, let's say finance, right? We don't want to keep their data in the employee table, so we can simply remove those records, and for that we need to use the delete command. Now these are something which is basically transactional control language, TCL, which means the transactional control language. And when we were talking about the transactions and everything, right, and there was one more thing, right, acid properties, atomicity, consistency, isolation, durability, and other things. So those were actually meant for the transactions. So everything, whatever operations we will be doing, right, whatever queries we will be writing to query the data from database, that is something like the transactions will be happening, like reading some data and then updating in it, and then writing, right? And in order to achieve the fault tolerant part, right, what we were supposed to do, we or when I was explaining the life cycle of transaction, so there were actually some states, right? First your transaction will go into the active state, and once the computation has been done, like first the computation will happen in memory, right? And whatever result will be there, that will be pre-committed or middle state where the result has been computed, okay, and that result has been stored in the main memory, okay. But in order to reflect those kind of changes, or in order to write those kind of changes, okay, what we need to do, we need to do a permanent commit, right? So permanent commit, when we will do it, then those changes will reflect in the databases. And that is why this TCL commands are important. The two important ones are the commit. So commit will, what it will like do, if we have performed any kind of these data manipulation, let's say operations, the insert. So insertion means we are adding new records, updation means we are updating some records, deletion means we are deleting some records. So we need to commit these changes, right? So that will be a two-phase commit, definitely, right? First those changes will be written in the middle state, or that will be pre-committed, and once we fire this commit, that means now we are making, or we are pushing those changes somehow to the active database. And save, we can say the rollback part was also there. So whenever we, let's say, made some changes, right, and we thought those changes were by mistake, or those changes can impact our database, we can quickly fire this rollback command, and rollback will basically take our database to the previous consistent state. So that was the TCL. And the DQL, data query. So query, also these things, whatever operations here we will be using, those will also be the queries. We are, let's say, inserting something and we need to write a proper syntax. But here the query which we are referring here, that means to retrieve the data, reading the data from a table. So when we will read, we will select some columns, or we will actually can print the all the columns which are present in the specific table. And for that we need to use this select command. So select command, what it will do, we will just like mention some of the columns, or like all of the columns of any given table, right? Select some employee ID comma employee name from table, right? And we will get that data. So here we are querying, we are retrieving the data from the table, and for that we need to use the select command. And then data control language, right? So here we have actually grant and revoke, these kind of two SQL commands. So in the beginning, when we were talking about the advantages of the relational database management systems, right? So the main advantage was again the security part, right? Let's say in your database you have stored some critical data, okay, and that database is something, we are working as a team. In a team there will be multiple members, and you don't want to you don't basically want to let other users to access that critical piece of data, okay. In that case, we somehow need to put some restrictions on those tables, like who can actually, let's say, manipulate the data on the table A, who can actually just query the data which is stored in table A, who can actually delete the data which is stored in table A. So that means these permissions, right? Being an admin of a database, I can actually decide which user can have what kind of permissions. So when we talk about these permissions and giving these permission to any specific user, that can be done with the help of the grant command. And similarly, let's say few of the permissions were given to any specific user, and now we want to actually remove those permission from that user. We can use this revoke command, and those permissions will be completely like gone for that particular user. So these were the important categories and these important SQL commands which lies in different categories based on their characteristics. And now let's look at the kind of operations we can do with the help of SQL, and what kind of operations we can perform on a database or the data which is stored in any specific table. So see, there can be n number of operation based on the business logic and based on any logical concept. But here what I have listed, those are very often used operations, right? These are some specific things which we keep on doing probably on daily basis while interacting with any table stored in a database. So like where clause, this works like a filter condition, right? Let's say you have a table, and from your table you want to pull some specific set of records based on some specific filtering condition. We need to use this where statement or where clause, we can also say. Order by basically, let's say you retrieved some data, and on your display on your computer screen you want to display it in some specific order, right? Let's say ascending order of roll numbers, descending order of roll numbers, and similar type of condition. Then we need to use this order by command. Group by command is basically like we want to perform some aggregation, or we want to perform some mathematical aggregation operations, right? So group by and aggregation function will be something mostly they will be used together, right? Let's say we want to find the sum of the salary of all the employees who are working in the finance department, right? So first what we will be doing, we will make a group, right? Group based on the column finance, or based on the column name which is department, and where the value is the finance. We will make that group, and within that group, whatever employees are there, I will pick their salaries and will sum it together. Okay, so that's how these aggregation and functions and group by operations will work together. Next, the case when statement. This is again very simple. This is like a if else condition, right? In the DCL category, like data it will be a kind of if else condition in the data query language, like whenever we are selecting some columns. So in that case, what can happen, we can display the data based on our some conditions. So very simple example, let's say you had a data for the student table, right? And student roll number, student name, and the marks they have obtained. And now on your output screen, you want to display a simple result, right? Student name, comma, grade, right? Let's say a person who got 90% grade, who got the 90% marks, that will be given a grade or A plus grade. So here we need to apply a if else condition in our select statement, like select student name, comma, we will apply some if condition. Let's say if marks greater than 90, then print the value A grade. If marks less than 90, greater than 80, print the grade equals to B plus, something like that. So for that we can use the case when operation. And then the joining operation, this is also next topic which we will be discuss. So this is also one of the next topic which we will be discussing after doing some query operations. And joining is something like in a database, right? There will be like n number of tables as well. Okay, and when we actually talk about the insightful information, okay, so there will be a need where we are supposed to join multiple data sets together in order to get the final result, right? Let's say we have three tables. So in first table there are 4 columns, in second table there are 3 columns, in third table there are 9 columns, and I need 2 columns from table A, 1 column from table B, and 3 columns from table C. And since we already know that this is a relational database management system, and when we are talking about these data sets, so there will be some referential integrity among these tables, right? With the help of foreign keys, we can somehow interact with, or we can just merge the information present in both of the tables and get the desired result, right? So similarly, in this case, join operation will come into the picture, because here we are interacting with 2-3 data sets together with the help of foreign keys, and that operation will join. That means we are joining two data sets with the help of some keys, with the help of some column names or some conditions. And similarly, union operation, this is a kind of you can say concatenation of two data sets, two data results, or two query outputs which are having same number of columns and same name of the columns as well. So these are some very like important one as well. We can say the basics as well from the SQL perspective, but very often used, right, in our day-to-day activities. These will be the common operation like we will be doing most of the time. So that is about the theoretical part of the SQL. Now I hope you understand what are different queries, statements, categories we talked about. Now in the next part, what I'll do, I'll open the console, right? In my local machine, I have installed a relational database system, that is the MySQL. And MySQL, I can actually access it and I can operate on it on my command line itself, right? It gives the access to manipulate the data in the MySQL using the just Linux type of terminal, where I can type these SQL queries. First, I need to make a connection to my database, and then I will be able to fire these queries. So I will try to execute some of the basic and important commands one by one, so that you can practically see what is query, how it is being written, and how it is getting executed. All right, so here, this is my SQL setup here, you can say. And here I am using the MacBook, and you guys can also follow different instruction. Let's say you are using a Linux based system, or you are using Windows laptop, right? So here what you can do, you can follow that particular instruction, because these are the open source databases, MySQL at least, right? So what you can do, you can follow those instructions, and even you can set up or you can install these open source relational database management system on your local machine, and you can play around it. So similarly, what I have done in my MacBook, I used the instruction and installed MySQL. And as I was saying, here like this will actually allow me to open this MySQL shell, you can say, or a console access, where I have a control on that particular MySQL DBMS, and I will be able to just perform different SQL queries, and I will show you how everything will work here. So whenever like you will install MySQL in your local, right, so what will happen, by default it will create some databases which will be actually used to hold some metadata information related to the MySQL database itself. Okay, so let's say you have an empty database, or even let's say you have any existing database, and you want to actually see what is stored in that database, or any database has been already created. So there is a specific command for that, show database. So that will be a command, right? So here you can see, right, these are the some you can say system configured databases already created when we installed MySQL in the local. So whenever even you will install, you will be able to see these things here. So that happened. Now what we will do, first we will create our own database. You can see, right, these existing databases already exist. We will create our own database, and within that database we will create 1 and 2 tables, and I will show you different commands, whatever we talk, different operations, even we were able to do it, right? So first, how we can actually create the database in MySQL. The command is very simple, create database and database name. So here we will create a database with the name of scalar. So now here we can see, right, this is a successful message, query okay, that means completely successfully executed. And now if I again run this command, show databases, so now this scalar database should be listed here. Okay, so now we can see this database has been created here. Now I need this database, because within this database I will be creating my own tables, right? And within those tables I will store some data. So Now database has been created. So how I will enter into that database? So for that we can use this command, use database, right? So here I just need to mention this database name, use scalar, right? So here we can see this command, database change, right? That means now I am into this scalar database. Whatever table I will create, delete, update, or any operation I will be doing, that will be performed the tables which are stored in this database named as the scalar. So here this success message actually refers that thing, and the command is use database name. So scalar was the database which we created. Now this thing is done. So let's recall our the categories, right? So there was data definition language, DDL, and within that DDL we had the create command, we had the drop command, we had the alter command, right? So here what we are going to do, we are going to create an employee table first. We will create an employee table. It will have 3-4 attributes. So let me show you that how we actually create a table in MySQL. So create, the syntax is create table and then table name, and within this small brackets we need to mention the comma separated column names and their data types. So here what will happen, first we will actually say there should be a column named as the employee ID, right? And employee ID, that will be of integer type. Now there should be second column, employee name, right? And here if anything is of string type, right, or it will hold some kind of characters, so there is no as such data type named as string, but it is a like varchar, right? Varchar means it is representing the characters, you can say, okay, or those values, right? A B C D E F D and other values which comes under that character variables. And employee name varchar, and within that varchar, right, after this varchar we can create one parenthesis and we can define the length, right? This employee name will hold, let's say the employee name can be of just 50 character, right, max. So we can define here, and there will be a column named as salary, right? Salary, let's say we are declaring it as a integer and we can do it as a int. And last will be the department, okay? And here I am going to use department ID only. I am also like here I will also create some IDs, or here I will create one more table name as the department, and I will show you like in later when I'll end up with most of the commands that why I used it. So if you remember, we were talking about the join operations, right? And in order to give you the example of join commands, different type of joins, I will be using that. So that's why I'm here creating a column named as the department ID, and that will be also of the integer type. Okay. So here we can see the syntax, right? Column name, its data type, comma, another column name, its data type, comma, another column name, its data type, comma, another column name and its data type. And after the comma we can give some integrity constraints as well. So here first integrity constraint, or the basic one, is declaring the primary key, which column we want to use as a primary key. And here we know employee ID is something, here we know employee ID is something which we can basically declare as a primary key here, right? So after the comma we can use this constraint primary key, and in the bracket we can actually mention this employee ID, right? So that means this will be used as the primary key. I'm just not sure whether this underscore should be used or not, like whether it should be written like this or this, but quickly let me check. We will get the error if it is not like that. So here salary, integer, department ID, primary key is there, right? And now semicolon, and simply let's do it finally. So it's created here, right? So how we actually created the table? So create table, keyword, table name, small brackets, your column name, its data type, column name, data type, comma, column name, data type, so on. And at the end we can give different kind of here you can say the constraints, or here we can actually call out different kind of you can say the integrity constraints we can apply here itself. But these are the some thing which is related to the primary key related, so here we have mentioned it in that way. So the if we want to actually create any column, or we want to declare any column as a primary key, we can do it in that way. Primary key keyword and bracket the column name which will be used as the primary key. Now if you remember the concept of primary key, that means that cannot be duplicated in that particular table. So if we are trying to insert any of the record which hold the value of primary key and that already exists with different record in the existing table, that time we will get the error because it is violating the property of primary key. So now our table is created. Next step would be to insert some data, right? To enter some data. So here this create command, we checked that part, data definition language, because we have created the structure. Now we will come to the data manipulation. DML manipulation means we are manipulating some data, or we are pushing something, right? So for that, what we are going to do, we are going to write the insert command, that how we are going to insert the data in this particular table. Yeah, so let's look at the insert command. So the syntax is insert into and insert into the table name. Table name is employee. And since here what we are going to do, we are going to insert the all the values, right? So we can simply say insert into the table name. We are going to insert values in all of the columns which are mentioned. There could be multiple cases where you do not want to insert values for every column which is mentioned. For few specific column, there is a different syntax for that, right? Writing the this insert command. In that case, in front of this employee table, we need to mention those column names as well, for which we are only going to insert the data. But here our need is to insert the data for every column, right? One record will have the data for every column which is mentioned here. So that means insert into employee. So automatically it considered all the column names here. Then values, right? So within this value, so here we need to follow the sequence as well, right? Because this table structure is a like well structured. Those columns are not randomly placed. So the way, or in the sequential way, we just declared our variable or declared our column name in this table, right? We need to also pass the values in the similar fashion. And if we want to just shuffle or reorder of the values in this insert command, then we need to mention the column names in front of the employee as well. So the sequence we will follow in front of this employee table name, same sequence of values we need to provide in this values keyword. So here the first value should be employee ID, right? So let's say employee ID 1, name, that is of varchar type, let's say Shashank. Now third column is basically the salary, let's say 9,000, right? And now department ID, that means here for the simplicity, you think there are 5 departments in that specific company. One is IT, one is software, one is finance, one is the you can say the HR department, and fifth is the basically operations department. So we can assign simple IDs to each of the department, and that is we have done here. So let's say department ID 1, and later we will decide like which kind of the ID we will consider here, right? So for let's say software department, we have assigned department ID 1 and something like that. So we'll look at in the later part. So here we can see, right, query, okay, one row affected, that means data has been inserted. So quickly here, let me try to show you that thing, right? Let's say now this record has been already created. This record has been inserted in the particular table. Okay. Now I was talking about this primary key constraint. Okay. And if I try to insert the data with the same primary key, and here let me just tweak or this value, right? Let's say instead of Shashank underscore 1. So, and let me just trigger it. So duplicate entry 1 for key employee. Here we can see, right, this employee ID is a primary key, and that's why this error we are getting, because the constraint or the property of primary key is that it cannot be duplicated. That's why our database was also smart enough, and since we actually described these things in the beginning while we were creating the table structure, that's why we can see this error here. So now let me record, or let me create another record. Let's say 8000, and the employee name was, let's say, Rahul, and employee ID was 2. So record inserted. Now let me create a third record, and he was also in this one department ID, and his name was Ankit, and his employee ID is 3. Now let me insert one more record, and he was working in department 3, and he was earning 7500, and his name is Anil, and his employee ID is 4, right? So far we have insert 4 records. All right, so this is done. Like, we have at least done one part, or we performed one command in this DML one, right? Now quickly I will show you, or I will actually tell you the DQL part, the data query, how we actually do this, or basically querying the data. Okay, so for that we simply remember select operation we need to do. So let's quickly check out what is the syntax for that. So select, right? Select what we will be selecting from one specific table. We will be selecting some column or all columns of it. So let's say we want to display all the columns of one specific table on the output screen. We can simply use this character star. Star represents all columns of that specific table. So select star from table name, which is here employee. So we can see this entire well structured data here. Employee ID 1, Shashank, Rahul, Ankit, Anil, right? So these are the 4 records we have inserted. So now you also know how to actually use the select command, and since star was there, that means all the columns were selected. Now let's say we only want to display employee ID and employee name column. We don't want to display the salary and department ID in our output. So we can just simply mention comma separated column names, and that's how we will be able to see this output here, where only employee ID and employee name is here. Now since we have covered the select part as well, I will quickly show you that how we were doing the basically update command, and how we can even do the update command. But after that, I will first show you very basic operations we were talking about, right? And after that, that update command will make more sense, because I will be using some filtering condition in that. So these are the some basic things we have covered: how to create a table, create a database, select the data, inserting the data, right? And after that, I talked about few of the basic operation, let's say filtering condition using the where clause, group by, order by. All right, so now let me do that. So first I will be working on the where clause. So let's say what we want, we basically want here the you can say all we from this input. Now we can see this data set, right? From this data set, what we want to select all those records, right? Or basically the details of those employees who are getting salary equals to 8000 or greater than 8000, right? So let's do that. So here what we will be doing, that means we need to display the entire or all columns. We can say select star from employee table where, this is a simple condition, like where salary greater than equals to, like even in the programming languages, these are something very common thing, right? These logical operator, conditional operator, and same thing we will be using here in SQL as well, right? Because we need to perform these different kind of operation. So where salary greater than and equals to, right? Or basically say greater than or equals to 8000. And if I mention this, Based on this input table or whatever data is stored in our table, ideally we should get only these two records, because these two records are only matching this condition, not these two. Let's do that. So here we got this output, right? Now you simply know the how we actually apply the where clause. All right. So now this is done. Since now I have explained the where clause, I can actually tell you how we were actually, or how we can actually modify the values or update the values. Because see, whenever we will be updating something on a table, right? So there could be two cases. Ideally we are overwriting the column value for any, let's say, specific column, or we are trying to overwrite it, we can do that, right? But there could be a situation where we just specifically want to modify a value for a specific record, right? If you remember, I explained that example. For any employee, we want to update the column value of the department name. So here what we are going to do, we are going to update the value, right, of employee who was Rahul, right? And now his salary has been incremented from 8,000 to 10,000, right? So let's say how we will be actually doing it. So for that we need to follow the update command. So update this one, like the syntax is update table name, employee, update table name. Here we will be reassigning something. So for that we need to use this set keyword. Set salary, like set value of salary column equals to 10,000, right? So update employee table, and within that employee table, what we need to do, we need to set salary equals to 10,000, right? 10,000 where 10,000 where we can either use the employee ID if we know it upfront itself, and we can even use the employee name. So here I guess employee name is a perfect thing to use. Employee name equals to Rahul, right? So here we can see query okay, rows match. That means whatever filter condition we applied, where employee equals to Rahul name, that means our database or query was able to find one record in the database where the name was Rahul, and there what it did, it changed the value of salary from 8,000 to 10,000. But how we can verify? We need to again run the select command, right? So here just look at this output and look at this one. We stored earlier this one here, value for the salary equals to 8,000, but now it has become the 10,000, right? So I hope the update command is also clear. So we have done the where clausing, we have done the insert updates. Now I was talking about the order by clause as well, right? So ordering, let's say we were using this, here we are displaying this data, right, in any random order, because right, we can see the one order is simply employee IDs, and that is why, because in this sequence we inserted the record. But here let's say we want to display the output over the screen in the ascending order of salaries. So how we will be doing it? So here select star from employee, simply add the clause order by, and we can mention that which column we want to use for the ordering. So here we will be using the salary column, and we need to mention whether we want the values in ascending and descending. So for that we can use this DESC, that means descending. By default, if we use the order by clause on any column, it will be in the ascending order. Now let me just run it. So here we can see this, our output is completely arranged or ordered in the base of this salary column. So 10,000, 9,000, 75 and something, right? So this is done. Now we will talk about one more important operation, that is the group by, right? So group by is something which we will be looking at now. And if you remember, I talked about grouping means, let's say we know this is a set, right? Again, taking example of employee table, there will be a software department, IT department, and any other department. And if we want to just calculate the salary of those employees which lie in that specific particular kind of department, we first need to group on that column and then perform the aggregation operations, right? So here we know like these, even we can see, right, these two records like Shashank and Ankit belong to same department, and let's try to perform the same query here. So here what we will be doing, so select, and we will be doing a group by on the department ID, right? So here with the group by operation, the catch is whatever column we will be using with the group by keyword, only those can be used, right, in this final select column. And apart from that, if any column which were not the part of group by keyword, that can only be used with the aggregation function, right? So here, since we'll be doing our group by, right, first let me type the later part. So select, we will be doing something here from table name employee, and we will be doing the group by based on the department ID column, right? So here in the final output, what we want, if we will be doing the select star or anything, obviously this select operation will fail, because with the whenever we will be doing the group by, only the column which has been used in the group by keyword, those will be the part of the select, right, of the output display. Apart from that, whatever column we are going to use, that will be, or that has to be a part of any of the aggregation functions, else we cannot use it. So here what we wanted, for every department we wanted to calculate the sum of their employee salaries. So if we perform this sum salary, right, that means for every department it will do the summation. For department ID 2, there is only one employee working, so the total sum of salary will be 10,000. For the department 3, only one employee working, Anil, and the total sum will be 7,500. But for department ID 1, there are two employees working, and one employee is working earning 9,000 and another is earning 7,000. So 9 plus 7, 16,000 total we should get for like different kind of departments. So here one more thing I would like to highlight. Let's say in your table, input table, there is one column, right, and it has some weird name, but when you are displaying it over the console or the output screen, we can even provide it a alias name, any different name, and with that alias name it will be displayed over the output. So here we what we did, we pass this salary column in the sum function. So sum function will add those numeric values together, and here this output column will be named as the salary sum. We can name it like that. So whenever we are doing this way, like as or this alternative name, that means we have provided the alias name. So let's do this quickly. So here we can say this output, right, whatever we calculated perfectly, we are getting it here. So that's how this group by, like there will be obviously so many logical and complex things as well in order to do with the group by operation. When we talk about the analytical thing, or as I was talking about the big data profiles, where there is a lot of data analytics needed, and advanced SQL part will also be used there. So now we are done with the group by operation as well. And next we need to understand the join part, right? We talk about the join operation, but before actually showing you the join, right, how the entire join operation, different joins are working, first I would like to elaborate what are different type of joins available, right, and how that actually work. And after that I will come back again on this console. I will create a table with the department, and we'll try to just demonstrate those different type of joins. Alright, so now we will look at the different type of joins in the SQL and why there is a specific section for joins, because honestly telling, this is something a very costliest operation in the entire big data systems as well. Or whenever, like not only the big data, if you're performing or you are doing some queries on a database which is containing multiple data sets, right, attributes from different data sets, then we somehow definitely need to join those data sets together. And whenever it is about joining two data sets, that is the costliest operation as well, and that will take time. Things needs to be optimized. We also need to take care what kind of join we are going to use based on our needs and based use cases. So that's why the joining is something which is the important concept, and that's why different section for it. So first, definitely we will understand the joins from the theoretical perspective, like when we write the SQL queries, then how different joins work and how this data will look like. And after that, I will also demonstrate same thing, same type, like how we actually join the data sets together with the help of that demonstration using the MySQL. So let's look at that theoretical aspect first. So joining, again, with the definition, it's clear, like just bringing 2-3 data sets together based on some condition, based on some columns, right, based on some matches, right? If you remember, when I was previous slides, when we talked about the key concept and the ER diagrams, so there I told you, right, there will be a kind of key which is a primary key of one specific data set, but then that can be referenced as from foreign key in another table, and using those kind of key columns and anything, we can simply do this join operations, right? So there are actually 4 type of joins we have. So first is the inner join. So in inner join, what happens, right? Let's say there were some records, there were, let's say, M records in table 1 and M record in table 2, right? And based on the foreign key concept, let's say there will be a key which is a primary key of table 2, and that we have referenced in table 1 as well, right? Because that was needed. Okay, I will show you how that was needed. I mean, when I was talking about different operation, I only created department ID. I didn't create the department table. So when I'll explain that, that will be quite clear to you. So here you can see, or you can say, this is our department table. Okay, and this is our employee table. Employee table obviously needs the information of employee department, but here what we did, we used the department ID. Okay, because department value can change later. Let's say today department name software, and that's ID is 2. Let's say after a few years we just finished that software department, or we just remove that software department from that organization, so that department ID 2 can be assigned to something else. Let's say even sometimes we changed information, right? How and why actually these kind of segregation is needed, probably we will understand in the later part as well, when we will talk about the data normalization. But on a higher level, you can understand the difficulties we may face, right? So let's say there was one simple table, and for every employee ID we mention the employee department name, right, in front of it. And let's say there were 10 million or something like that data you had. So in that case, what will happen? Let's say there were 1 million employees who are working for the software department, and after some days you change the department name to software INC, right? Or software, let's say software enablement, something like that. You change the value, or right? So in that case, what will happen? You need to go in your original table, and in your original table you need to traverse, or you need to find those 1 million records first and update the values with the help of update command. Obviously it's a something which shouldn't be entertained, and it becomes a bottleneck when we are performing records in quite real time, like multiple joins are like needs to be done, right, in or multiple updates are happening in a real time, something like that. So that cannot be a thing which we can afford. That's why we will segregate that kind of table, right? And here we segregated a department table, and it has the department ID column which has been referenced here. So later if I want to pull the information, or later if I want to pull the information of the department name for any employee, I can use this department ID, because I know the department ID of that particular employee. I will join it with the department table using the department ID column, and I will bring that column, simple, the department name, and that's what we have done. So inner join is something, right, based on this Venn diagram you can even understand. So inner join, there were some records in table 1, there were some records in table 2. So if values of those keys which we have used from table which will be on the left side and the table which will be on the right side, if values are matched, okay, only those records will be picked as the output results. Apart from that, everything will be discarded because there was no match for it. Apart from that, everything else will be discarded because there was no match for it. So here, that is why only this middle part has been colored with the yellow, because apart from that, whatever was not able to matched, we will just remove it, or anything we are not going to consider it. So that is the fundamental about the inner join. Next, about the left join. So in the left join we have this table and the right table. So in left join, what will happen, whatever records have been matched, right, from the table 1 and table 2 for the same values, those will be pulled, but all the records for the left table, whatever we have used in the left side, will also be present, and in front of it, whatever values of the right side table will be populated as null, right? There will not be any value for those columns which are coming from the right hand side table, because there was no match found for those values, right? Similarly, this right join is a vice versa of left join. In that case, all the join which were matched, that will be present, but the records from the right table will only be present as a populated values. But if there was no match with the left table, so the columns which are coming from the left side, those will be populated as a null. So in the full outer, this is the last type. So in full outer, what happens, everything, like if match has happened, those records will come together, and left join will also come into the picture, like those keys which were not, like those keys which were present on the left side table but not right side table, still those values will come from the left hand side table, and the right hand side column will be empty. Similarly, those values which were present on the right hand side table and there was no match for those values in the left hand side table, so the right hand side table columns will be populated for such keys, but the left hand side columns will be populated as a null. So this is the fundamental about the full outer join. So these are the 4 important types of the joins in the SQL. And theoretical aspect, I hope it is clear to you. Now I will quickly go back to the MySQL console, and there I will perform few of the queries in order to demonstrate these 4 type of joins. Alright, so previously we saw different operations on this table of employee name, right, in the database named as scalar. So now we talked about the join operation, and here now I will demonstrate these 4 type of joins: inner, left, right, and the outer join. So first, here in this table, right, if you can see, this is our input table named as the employee, and here I have employee ID, employee name, salary, and department ID. So first, as I demonstrated, I need to create one more table as named as department, and I will use it for these join operations, right? So quickly, let's create one more table. Create table name will be department, right? And in the department table, there will be only 2 columns: department ID, which will be primary key as well. So department ID integer type, and department name, that will be of varchar, and length, let's say, can be 100. And again, a constraint will be like I am going to use department ID as a primary key for department table, and now since it is present in the employee table as well, so here it will be called as a foreign key, because this department is the primary key of a department table. So department ID should be the primary key here. Now the table has been created. So quickly I will insert few record as well in this table, and those records will be like let's say insert into department table, and values will be, let's say, department 1, and that department 1 is for IT. Okay, we have inserted, and there is another department, let's say 2, and for that department name is software, right? Now this is also done. There is another department, let's say department ID 4, and that is named as, let's say, finance. And there is one more department named as, let's say, ops department, operations, and there is one more department named as, let's say, HR department, and the ID is, let's say, 8. All right, So now data has been inserted into the department table. If we quickly want to have a look at all the data which we have inserted in the department table, we can quickly check, right? So now it is here. So first example was to just perform the inner join. Inner join based on the condition or based on its technical aspect, we know if there is a match for any given key value, right? Whatever key we are using for the join condition, if match has happened, only those records will be there in the output table. Okay, so here now we also know how our this table looks like, this employee table. And in the output, what we actually want to do, we want to just get this information. Let's say we know these two data sets are present for us. We want to get the information, let's say Rahul and in which department he actually works. Only two columns we need to print. So employee name we can get from the employee table, but the department name we will be getting it from the department table, and we need to join it. So let's do that. So select, and here we need the employee name, comma, we need the department name as well. I will show you few things which I haven't write here, but one by one. So in the final projection, we have selected these two columns. From left side, like whatever table we will be mentioning, right, that will be follow this sequencing of tables as well. So from employee, and what we want to do, we want to do the inner join with what kind of table? The table name is the department. On, these are the like specific syntax and keywords to perform the join operation. So first, like from table will be on the left, kind of join operation, like the second table. On means condition, the condition we want to mention here. Okay, so here how it is going to happen. So what we want to use from the employee table, we will use department ID column, right, for a joining perspective. And from the department table, we will also use the department ID, because in employee, department ID has been referenced as a foreign key. So employee table name, like in the on condition, how we can access the column of different tables, table name dot the column name of that particular table. So employee dot department ID equals to department table dot department ID. So on, that means this condition should be applied while matching the condition or while matching the records. So the department ID column has been used here. And similarly, how we are pulling these columns. So from employee table, I need, like once the join is done, give me employee name column from the employee table and department or department name column from the department table, right? So this is done. Let me run it. All right, so we got this information here, right? And how this would have done, this is very straightforward, right? If you look at this table, right, here 1 2, the department ID 1 2 4 5 8, right, that is here. But now what will happen here, in this employee table we can see only records for department ID 1 and 2 are present, and here department ID 1 is IT, 2 is software, and there is one more employee who is working in department 3 and his name is Anil, but we didn't get any output for the Anil here. Why? Because there was no match present. So inner join is all about wherever the match has happened, just give me those records. That is the simple straightforward. Now let's actually make it more clear to you that how it will even look like. So what I will do, even from the department, I will do this star, like from the department pick all the columns, and from the employee pick all the columns. Okay, so left, from whatever is on the left side, that means this is coming from the left table. So employee ID, employee name. So department ID from the employee table matched with the department ID of, you can say, the department table, and that's how we are getting the record. Now let me quickly just change this inner join to the left join. And if you remember, in left join, if match has happened, we will get that record. But if there is any record which is on the left table and there is no match for that, all the values will be there, like will be present from the left hand side column, but for the right hand side column, those values will be populated as null. So now let me change this inner to left, right? So here we can see, now when we did the inner join, we didn't get any output for the Anil. But now here, although whatever matched happened, whatever was matched, so that output we also got. But here for the Anil, there is no, right, there is in this department table, right, you can even see there is no entry for department ID 3. That means that match didn't happen. So at least these values will be present, right, in the output, because these were populated on the left side, but for that we didn't find any match. So in the output, these will be populated as the null. So that is the concept of the left join. From the left, data is coming, but if match was not there, data from the right side is null. Now let's quickly check the right join operation as well. Like left join has happened, so right join is again very simple to understand. So here, right, what we are looking, the output is bit different, because in condition, obviously match is being checked, but the priority will be the right table, not the left table, because when we did the left join, obviously the left hand side record was present here, and for that corresponding right side values were populated null. But when we did the right side operation, so that means match is being checked from right to left side, not the left to right side. So for the left to right side, when matched was checked, so obviously for department 1 there was a match. But when we started checking for this one, right, for this department ID 4, there is no match available in the left hand side table. That means we need to discard it. Similarly for 5 and similarly for 8, not discard means these left hand side values will be populated as null here, right? So this is as simple as that, and that's how probably we can just check how these records will get joined together and how it will look like.